student, a teacher, STEM career professional, or a parliamentarian. For young people looking for a STEM career, you could find your dream job right here today at the GSG STEM Expo 2024. And I know I have collectively nearly 40 years of having worked in CSIRO and Australia's chief scientist, and it's been an amazing and fulfilling career for me. And I hope to think that maybe I've made a difference. Anyway, we have a schedule of speakers all day today. And so it's time to get that ball rolling with our first guest speaker of the day. And I'd like to welcome to the stage Geoscience Australia's Chief Scientist, Steve Hill, and Director of Strategic Science, Dr. Verity Normington. Over to you both.
Thank you. Thank you, Kathy. Isn't it exciting? Bring us all together. Great to have the people that have just come in through the door join us. Welcome. I'm really excited that everyone's together, but I'm also really excited that we've got Catherine Bennell-Pegg, who is, of course, the first female Australian astronaut joining us today. And isn't space and space travel exciting? And wouldn't it be an amazing experience? I often wonder about it, and I often think, what would it be like if this became commonplace and something, if space travel was something that we were all able to do? And the first thing I wonder is, what sort of transport would we use and have for our starship, if you like? I've thought about it, and a few of the luxuries that I'd really like to see, firstly, I'd really want it to be fast. You want to be in a fast starship as you're traveling through space. So something 30 kilometers per second is pretty fast. You'd be able to go from London to New York in about 3 minutes. Also, the second thing is you'd want to be able to pack a lot of luggage. You'd want to have things like water, food. You maybe even want to grow and make your own food. You'd want to have materials to make shelter, and also all the high-tech things that we love to have in the world too. You'd also want really cool things to do and places to go so you don't get bored on that space travel. And then lastly, you wouldn't want to just do it alone. You'd want a lot of room for passengers. Maybe your family, hopefully your friends. But let's be bold. Let's have a spaceship that holds 8 billion people. That's extraordinary, right? Now that all sounds like make-believe, but here's the reality check. That already exists today. And that means to travel through space with all of those things is what we call planet Earth. It's our planet, it's where we live. And you think when you look at that, you just think, well, that is incredible. Wouldn't it be exciting to know more about it, how it works, how you can drive it, and how we can best live with this incredible thing? We often take it for granted that we live on a planet. We forget that. We pave it, we concrete it. We also forget that we are traveling through space, and those things have an impact on our lives. I think that's really important. For Australians, we're responsible for a part of the planet Earth. And that's really important for us to be mindful of. That includes the exposed bit of the continent, but also the oceans that surround Australia, and also a bit of Antarctica. And how we live and connect to that part of the Earth really determines everything about how we live and the lifestyle that we have. And the part of the Australian government responsible for our knowledge and science of the Earth is Geoscience Australia. That's who we are, where we're from. And we do a diverse range of things across our continent and the surrounding oceans that Verity will soon talk to you about. But today we want to share the passion and excitement of a career working as an earth scientist in government, particularly at Geoscience Australia. We are the people that provide information to sustain our lives, manage the environment, as well as getting to connect with amazing places. We're the agency of where on Earth. And You want to know this because remember, everything happens somewhere. I'm going to hand over to Verity now. Thanks, Verity.
Thanks, Steve. Hello, everyone. So, earth science is a big part of what makes Australia what it is. Dazzling landscapes, natural beauty are central to our identity. But earth science plays a much bigger part than just the rocks that you can see on the surface. When you flick the switch, when you turn the tap, when you order a pizza, earth science contributes to all of them in big and small ways. So let's explore flicking the switch. It might be a light switch, it might be the power button on your laptop. Most of the materials that go into the circuits and wiring come from the earth. Things like copper for the wiring and aluminium for the circuits were all extracted from the earth. Whether they are newly extracted or whether they have been recycled and reused in those circuits. Silicon is becoming a very important element in the manufacturing of technology. It is used in computer processors, LCD screens, and touch screens. Resources need to manufacture wind turbines and solar panels, as well as our electric vehicles. They include cobalt, copper, manganese, lithium, all in quantities that we have never needed before. Ensuring we have enough of these materials is an important part of what earth scientists like myself and Steve do. But earth science is in your car, and probably not in ways you have considered. Not only do we need resources to build cars like aluminium and steel for the components of the car, but we also need copper, gold, rare earth elements for the car's computer. And we also rely on earth science to make sure we don't get lost while we're driving to that hot date at the cafe we've never been to before. Earth scientists, technologists, and engineers are working to make GPS and map accuracy the best it can be. Geoscience Australia is working towards 5 centimetre accuracy and more precise location information so automated cars know exactly where they are relative to gutters and trees. It's also really important so that when you order your pizza, it comes to your house and not next door neighbours. Observing the Earth from space is becoming increasingly important in monitoring the environment. Using satellite images that have been collected for over 3 decades, we can make observations that analyse the changes to the Earth. For example, how coastlines change to understand if there is a net loss or a net gain of sand at your favourite beach, or how mangroves in Northern Australia are bouncing back after the 2016 dieback that was caused by a very strong El Nino environment. During the 2019-2020 bushfires, satellite sensors detected areas producing high levels of infrared radiation. From this, an interactive digital map called Hotspots with near real-time locations of potential bushfires helped emergency services respond to that emergency. Now, water. Water is one of our most precious resources. Understanding where water can be sourced during times of drought is one of the most important applications of earth science in Australia. To understand this, we need to be able to look beyond the visible into the subsurface. Some of the more traditional earth science disciplines, such as geophysics and geology, can be applied to this problem. By transmitting a signal or a vibration through the earth and measuring the return of that signal, we can build and understand an understanding of what buried sediments and rocks are likely in the region. From this, we can create maps and models to show potential groundwater that is in that region. Combine this with the understanding of the geology and the landscapes through mapping and the chemistry of existing bore groundwater sampled from bores, we can help Australia become drought-proof. Now, earth science can solve just about any problem or challenge I can think of. Steve, are there any that you can think of that earth science doesn't solve?
No, I can't think of any, Verity. And I think that's a really important thing for us to remember, is that those telltale signs that we are on a planet connected to Earth, and the importance of the science that goes with that is all around us. Even here at Parliament House, think about it. we're in the catchment system of the River Murray here. All that stuff that's happening all through the Murray Basin, we're at the headwaters of that catchment. We're on this hill that we're on here is actually made of rocks that were deposited on the sea floor over 420 million years ago and contain evidence for the life and the environment that existed at that time. It's those things that really excites me and the people that work at Geoscience Australia. And that's what we feel is important to address the critical challenges that we have in our nation. We've barely scratched the surface on all the things that we do at Geoscience Australia here, but we encourage you to come and have a chat to us at the booth, find out more about it. We employ a great team of scientists, engineers, technologists, communicators, teachers, and also the people that provide the corporate functions that enable us to do what we have to do. So come and find out more about it at the booth, or come down to Symonston and visit us at Geoscience Australia. For Canberra, it's exciting. We have free parking. How about that? We also have great coffee, but you can touch a sample of the moon and you can see the areas where we detect and inform Australia about things like earthquakes. So come on down. Thank you for listening and have a great day today. It might just be hard to hear. Yeah. Yeah. We were wondering about having questions, but I think it might be best to come and talk to us because it's a bit noisy. It'd be a bit hard to hear the questions. So come and let us know. Thank you, everyone.
amazing organisms, plants and animals you could ever see. And so our role at the Australian Institute of Marine Science is really special in that we protect, we restore, and we are enhancing the health of these unique ocean environments. Another point to say is there is so much we do not know about our ocean environments. So whether you're here, whether you're interested in the biology, understanding whether that's the fish or the sharks, the sea cucumbers, or if you're doing physics, you might be interested in robotics, the technology, or understanding the currents. If you are studying chemistry, you might want to understand about why we need to study the pH. How are we going to mitigate against ocean acidification? Or if you're doing geography, you might want to understand about the benthos or the human geography. You might want to work with our Indigenous partnership teams. Because as I always say to my colleagues, we can have the best science in the world, which of course we do at the Australian Institute of Marine Science, but it's about perceptions, it's about attitudes, and that is what really changes the behavior. So we need marine scientists from all branches of science, technology, engineering, maths, whatever your interest is, there is a role and opportunity for you at AIMS. If you like diving or snorkeling, you're going to get more than your fill of that. If you like underwater gadgets and robots, then you might want to work with our technology team. And also, if you like exploring unknown destinations, you might come out on our research vessels. So it's really offers you a diverse range depending on what your interests are. The other point to mention about AIMS, as we affectionately abbreviate the Australian Institute of Marine Science, is our headquarters is in Townsville. We also have offices in Perth, and we also have a base in Darwin, as well as our office here in Canberra. And I'm just going to tell you now about some of the amazing slides and the photos behind me. The photo that you can see in your top left, this is a diver doing some work for our long-term monitoring program. This has been done for 39, nearly 40 years. This is the longest single data set in the whole world measuring the health of our reefs. We measure the hard coral, we measure the fish, because we want to understand how those reefs are coping with different temperature changes. And some of the work we do, one of our scientists has just been made a fellow of the Australian Academy of Sciences using IVF to improve fertility of corals. The other program I want to tell you about, so that yellow underwater vehicle, or it's an uncrewed vehicle, we have something called Reef Works, which is unique in that we have a test range where we can develop, test the latest technology, because some of the reef environments are really tricky to be able to navigate. And it's only by having very sophisticated underwater technology can we get to places that divers or any other method just can't get there. And then we also have one of the biggest challenges with reefs is the crowniform starfish. But what we do by understanding the biology, we're looking for the fish that like to nibble, that like to eat the crowniform starfish so that we can stop them eating too much of the coral reefs. So we have a lot of emphasis on nature-based solutions. And I'm sure you will have heard about the coral bleaching. As our seas are warming, we are looking for ways to be able to protect and offer solutions to allow our habitats to adapt. And then you'll see as well the top photo on your right, my left, the whale sharks. It's really important as we are developing the offshore renewables and other industries that we provide the baseline data to make sure that whale sharks, and we also work on pygmy blue whales, that they are protected, that the development does not interfere with their migrations. And then you will also see all the tanks, the National Sea Simulator. When I came for my interview 1 year ago today, I was blown away by the technology. There is nowhere else in the world that can measure pH, salinity, light. So we can predict, we can expose organisms to future scenarios. And by being able to do that, that means we can really start to plan how we're going to protect and restore our ocean environments. And then also to collect all this data, we also have experts in AI, machine learning. So if you're really on the mathematics side and the modeling and the computing, we need that latest technology to be able to understand this data. And then you'll see as well that our research vessels, we not only do experimental work in laboratories from a cell level to an organism level, we actually go out in the field and check what is happening in situ to be able to compare. But doing all this is about communities. It's about making sure that people who rely on the oceans, whether that's for jobs, whether that's for food, is really kept healthy. And I just want to finish and summarize by saying, you can see in this photo, the bottom left, this is my colleagues at AIMS with the first ambassador for First Nations in Australia. And what we do at AIMS, we do not go and do research unless we have the free, prior and informed consent from traditional owners. And our latest research, we are looking at how Indigenous knowledge, much of which is not written down, you will not find it in textbooks. We are looking on how to integrate decades, centuries of that knowledge, recognizing First Nations people as some of the first scientists. So I hope I've given you just a little flavor. I do get very excited talking about our work at AIMS and about the wonderful opportunities in marine science. As I say, whether you're interested in maths, science, chemistry, geography, whatever your interests, ocean science is a really diverse and fantastic opportunity. So I hope I've managed to share my enthusiasm, inspire a few of you, if not all of you. Please come and see me and my colleagues at the stand, at the booth. And if you have any questions, we'll be over there and be very, very delighted to speak with you. You'll also see that there are some various Twitters, websites, if you want more information, careers as well. Thank you very much for listening and have a great day.
Yes. Should be easy. Thank you. Good morning, everybody. It's awesome to be here as part of this event. I want to thank Australia's Chief Scientist, Dr. Kathy Foley, for having us here today and for this great event and bringing you together with us as well. And I really hope that you leave here today having discovered something about STEM careers in government that you didn't know before you came here. Quick introduction to me. My name's Cameron Sim. I am the Chief Environmental Scientist at NOPSEMA and the Offshore Infrastructure Regulator that I'll introduce to you a little bit in a minute. I'm here with my colleague Pauline Goh, who is a well integrity engineer, and she'll talk about her STEM journey as well. Recognising that this is an event that's broadcast over the internet, I want to acknowledge the First Nations people and the country on which we meet today and pay my respects to their elders past, present and emerging. Pulling out this slide, I think sort of gave a good impression of the STEM opportunities that might exist in the world that we regulate in. Our offshore area is vast. Australia has the third largest marine jurisdiction in the world at around 13.8 million square kilometres. And that's about 1.3 times the size of our landmass. Our offshore area covers waters that across three of the world's major oceans, the Indian, the Southern and the Pacific Oceans. And we have, as you probably heard from Selena, an amazing diversity of marine ecosystems across that area. So it's at this sort of scale and this sort of diversity that I want to show you that there are some really vast opportunities for careers in STEM in government and in particular in the area that I work in, and that's assuring that people can go to work and come home safely and that the environment's protected. So that brings me to who I work for and what we do. I work for NOPSEMA, the National Offshore Petroleum Safety and Environmental Management Authority. It's quite a mouthful. NOPSEMA is Australia's independent expert offshore energy regulator. We've been in force. We've been in place for about 12 years, since 2012. NOPSEMA regulates occupational health and safety, environmental management and well integrity in the offshore petroleum and greenhouse gas storage industries that operate in Commonwealth waters around Australia. And that's the light grey area you can see there in that map. What do I mean when I say we regulate those things from a STEM perspective? That means drawing on STEM skills to assess industry's risk management plans, to monitor industry's compliance with the law, to take enforcement action to ensure that industry complies if they are found to be non-compliant, and to investigate incidents and examine what went wrong and put things in place to ensure those incidents don't occur again. In 2021, NOPSEMA also was given the role as the Offshore Infrastructure Regulator, or the OIR. And the OIR is responsible for, just like NOPSEMA, for regulating work health and safety, infrastructure integrity and environmental management in Australia's emerging offshore renewables industry. So the OIR is just readying itself to be regulating when the applicable laws are finalised and brought into force by the Parliament. So people working at NOPSEMA, they often don't have very STEM sounding job titles. I, for a long time, was a regulatory specialist, for example. But this slide, I hope, will give you a bit of a flavour with some examples of the types of STEM fields that NOPSEMA draws on over the years to fulfil our regulatory functions. So the S part of STEM, the science part, we have numerous areas that have experience and knowledge in marine
fauna, biology and ecology, environmental impact assessments, underwater noise assessments, risk assessments, ecotoxicology, seabed ecosystems, emissions management and decommissioning. On the E part of STEM, or the engineering side, Pauline will talk a little bit more about that, but that's really important in relation to making sure that people go to work and come home safely. There are opportunities with structural, process, mechanical, petroleum and wells engineering, as well as naval architecture. And to keep the wheels rolling with all of this, we employ people with skills in data analytics and computer science, for example. So in terms of my own STEM pathway, just to give you a flavour for how I might have got here, I did my training in marine science. I'm essentially a marine ecologist, but these days I wear a business suit far more often than I wear a wetsuit. And I really wouldn't have thought I would have ended up here talking to you today when I started out as a PhD student or a graduate scientist. But I think that's what makes training and a career in STEM disciplines so interesting and exciting. What I think is really important about STEM training, and that's those broadly applicable skills that I've learnt throughout my training and career. Things like, how do you ask really interesting and important questions? And how do you do a critical analysis of a complex issue and come up with solutions and answers to those problems? So those things have been invaluable. So training in a STEM discipline can lead you down all sorts of interesting and sometimes unexpected pathways. I think I'm a pretty good case study for that. And with that, I'll hand over to my colleague, Pauline.
Okay. So picking up on the E for engineering and the STEM pathways, I'm actually a mechanical engineer by background, but over the last 12 years, I've worked all over the world. I've traveled to so many different places and working in the oil and gas space, primarily in well engineering. So I think my travels abroad and working in so many different places has allowed me to really appreciate where we work and also opening my eyes up to different perspectives and cultures. So if there's one skill that you can take away that will set you up for success, it's building resilience. You know, especially in this changing world that we live in today, if you're able to overcome those challenges, and they will come, that will set you up for success in the long term. So rewind 3 years ago, I joined NOPSEMA as a well integrity engineer. And what does that mean? So I'm part of the team at NOPSEMA that ensure law and regulations. So that means that the oil and gas wells that are being drilled, produced and abandoned are done so safely to ensure no harm to the people and no harm to the environment. So alongside these wells, we actually have quite a complex asset base offshore, and we see quite a wide range of them, from the drill rigs that are used to drill and construct these wells, over to the production facilities that extract and produce and store the petroleum products. And we see quite a unique complexities with all of them because we've got assets that are all different stages of the life cycle. We've got some that are a bit newer or relatively newer, where we see things like, the designs are getting more complex, more bigger than ever before. But then we've also got assets that are towards the end of the life cycle or already at the end of life cycle, where we see challenges in ensuring that the operators continue to uphold their maintenance commitments to ensure that the assets are maintained in good condition and repair so that they can be decommissioned safely in the long term. So if I just pick up decommissioning as a highlight, as I mentioned, there's quite a few assets in our region that are coming towards the end of life. And there's a wave of decommissioning activity right now in Australia and the decades to come. There's a study that shows there's the cost of this decommissioning activity is 60 billion Australian dollars. That's a lot of work to be done. So this involves the plugging and abandonment of wells, the removal of equipment, structures, facilities associated with them. And there are a lot of challenges that will need future STEM people like yourselves to come help us with in terms of regulations and in the industry as well. So as Cam mentioned before, we are getting ready to regulate offshore renewables. there are a lot of transitional skills between the oil and gas folks and the renewable space. And we're seeing that right now in NOPSEMA and OIR because we are regulating health and safety, the infrastructure integrity, and the environmental management as well. So as you can see from today, there's a wide range of STEM fields that are needed to contribute and realizing our vision. And that's to ensure the protection of the offshore workers, the workforce, and the environment. And I'm very proud to be part of that in achieving those goals. So I encourage you to come visit us at the booth. Cam and I will be at the booth on my right-hand side, and I'm happy to take any questions there. But otherwise, there's a QR code that you can scan, and we can sign up to the NOPSEMA newsletter to get regular updates from us. Thank you very much.
Morning. Hello, everyone. My name is Duncan Grove. I'm the Deputy Director General for Digital and Technology at the Office of National Intelligence. As was done at the opening of this event, I'd like to acknowledge the Ngunnawal people, traditional custodians of the land on which we meet, and particularly their continued care for country and traditional knowledge systems. I extend my respect to Aboriginal and Torres Strait Islander peoples here today, and I would also like to acknowledge our distinguished guests, including the Minister for Environment and Water, the Honourable Tanya Plibersek, Attorney General Mark Dreyfus, Minister for Resources, Honourable Madeleine King, and AFP Commissioner Reece Kershaw. To the Office of the Chief Scientist, led by Dr. Kathy Foley, thank you very much for the opportunity to come and speak to all of you today about a subject very close to my heart. More than 25 years ago, I graduated from university with a bachelor's degree in computer systems engineering. And I thought to myself, what now? I love STEM, but I wasn't sure how to make best use of my skills. Ultimately, I joined the Defence Science and Technology Group, who are also here to speak with you today. 25 years later, I'm still following my passion, working on science and technology in national security. This week, the Minister for Industry and Science, the Honourable Ed Husic, released Australia's new National Science Statement and Priorities. This makes clear that science and technology are central to our capacity to deal with the challenges, disruptions, and opportunities facing our country and our place in the world. Together with my colleagues across the National Intelligence Community, or the NIC, we are solving some of Australia's most pressing science and technology challenges to help keep us all safe. The Office of National Intelligence, or ONI, where I work, has a really interesting role in the NIC. We provide the Australian government with strategic advantage through all-source intelligence assessments and open source analysis, and by enhancing how the NIC works together to protect Australia and advance our national interests. So what is the NIC? You might be surprised to learn that intelligence is really a team sport. The NIC includes ONI and the Australian Signals Directorate, where I've been fortunate to work, and the 8 other agencies you can see on the slide behind me. If we can maybe put it up, that'd be great. It's crucial that we all work together, especially on science and technology. As you would know, working on complex science and engineering problems in maths or chemistry, physics or computer science relies on bringing many great minds together. In the national intelligence community, we bring diverse groups of people from all walks of life to solve really hard problems. Work that has significant implications for our country. In most cases, much of that work conducted across the NIC every hour of every day remains hidden, unless you are directly involved with these efforts. But I'm here today to shine a little bit of light on some of the STEM careers that you can have in the national intelligence community. First, you might be wondering, what is intelligence? In this context, intelligence is actionable information that has been collected, processed, analysed by smart people using advanced tools and techniques, and which helps decision makers reach an informed conclusion or course of action. There are many different tools in our intelligence toolkit. And it's not only tuxedos, vodka martinis, and jumping out of aeroplanes. Each NIC agency has a unique part to play, and STEM roles are crucial in them all. For example, right now, the NIC is collecting and analysing foreign intelligence, capturing and processing imagery and geospatial intelligence to build a picture of the world around us, investigating terrorism, espionage, and foreign interference that's targeting Australian interests, and analysing open source information to make sense of the constant chatter across social media and the internet. Here are just a few of the examples of intelligence activities that you could be involved with if you choose to come and work with us. At ASD, while most of the work is secret, not everything remains hidden. Recently, ASD warned the public about the threat of state-sponsored cyber attacks to our critical infrastructure. Thanks to ASD's programmers, computer scientists, electronic engineers, mathematicians, and other technologists, ASD is able to identify these threats and secure our critical infrastructure to keep all of us safe. Critically, this work is done in conjunction with our partners in the United States, the UK, Canada, New Zealand, Germany, Korea, Japan, showing how the work we do can have benefits far beyond our borders. You'll also know about ASIO, the Australian Security Intelligence Organisation. ASIO is the nation's security service. They are responsible for protecting Australians from threats to our security. ASIO recently revealed their Chamber of Secrets to show how critical STEM is to its operations. ASIO has a silent anechoic chamber used for testing listening devices. Alongside technicians working on bug sweeping electronics, engineers developing artificial intelligence tools, and data scientists analysing intelligence, ASIO has the full spectrum of STEM roles. National security requires more than just creative ideas. It needs creative STEM specialists to turn those ideas into reality. Across the wider NIC, we're gearing up for one of the biggest changes in technology that is in our history. Recently, the Deputy Prime Minister announced plans for a NIC top secret cloud, with technologists across the NIC and industry working hard to transform how we use technology to protect Australia and stay ahead of our adversaries. The TS Cloud will ensure that we are able to securely share and analyse Australia's most classified data quickly and at scale. It will also provide the opportunities for the NIC to work safely and securely to leverage artificial intelligence and machine learning. This is a huge project for the NIC, and it will require Australia's most brilliant minds across cloud computing, data analytics, and cybersecurity to implement. At ONI, my boss, the Director General of National Intelligence, is the Principal Intelligence Advisor to the Prime Minister. ONI relies on information from across our entire national intelligence community to keep our government informed about national security and intelligence matters every single day. At ONI, we have a significant number of STEM specialists who use their knowledge to help inform our senior decision makers about critical scientific developments here and around the world. It wouldn't be uncommon, for example, for you to brief me or the Director General on a science and technology issue that requires the attention of the Prime Minister. All the smarts in the world are wasted if we can't communicate concisely and precisely on difficult and complex topics like artificial intelligence or quantum technology. So, if using your STEM skills to protect Australia's interests and people appeals, please come and talk to the NIC careers representatives that are here today at our booth, or check out intelligence.gov.au. Across the NIC, we offer STEM entry pathways for everyone: cadetships, apprenticeships, graduate roles, and opportunities for people with experience in the workforce. We need people from all backgrounds and walks of life because to achieve the best outcomes, we need to tap fully into the diverse community that we serve. One story I'd particularly commend to you from intelligence.gov.au is a podcast with a first-generation Australian, an ICT graduate, just like many of you, and his journey to becoming the Chief Technology Officer at the Australian Secret Intelligence Service. And once you're part of our community, we work hard to keep you. We provide flexible work arrangements, competitive salaries, and generous leave entitlements to support busy and fulfilling lives. There are many opportunities to live and work overseas, and we support professional development and further study to get the best out of our most precious resource, our people. So again, if you want to use your STEM skills to work on the most interesting problems and make a real difference to the lives of all Australians, I encourage you to consider a career with the national intelligence community, maybe even ONI. With the benefit of 25 years of hindsight since I wondered, what now? I'm so very glad I did. Thank you, and please do come and have a chat at our booth.
Hello, everybody. My name is Joel Willis. I'm the Principal Director of Detection Capability within Biosecurity Operations at the Department of Agriculture, Fisheries and Forestry. So that's a long way of saying my team looks after the department's X-ray and detector dog programs. Joining me today is Grace Sun, one of our very clever molecular biologists based in Melbourne. And today we're also lucky enough to be represented by the Australian Chief Plant Protection Officer, Dr. Gabrielle Vivian-Smith, who's down here in the corner. Make sure you hassle Gabrielle with lots of questions throughout this event. And we also have our STEM DAF colleagues up in the back right-hand corner of the hall here in the booth, up with our team. So what do we do here at DAF? By partnering with industry, the department makes sure Australians have homegrown food to eat, textiles for clothing and timber products for housing. We assist in providing these same things to the world by creating export opportunities. And the one closest to my heart, we protect our landscapes, our animals, our plants by strengthening our national biosecurity system to keep exotic pets and diseases out. So DAF has a very strong science and research focus. A few examples are listed on the slide behind me. Just to name a few, ABARES, which is the Science and Economic Research Division of the department, whose mission is to provide independent research and advice. We work with animal and plant and environmental biosecurity, including national preparedness for exotic pests and diseases. And we also have the Innovation Pilots Initiative, which tests new technologies to enhance Australia's biosecurity capability. And you may have seen up the back there, Spot the robot dog is part of our Innovation Pilots team. So as mentioned up front, my team looks after the detector dog and X-ray screening programs, and I'm going to touch very briefly on both today. So Australia and New Zealand too, for that matter, are quite unique in that we are lucky enough to not have many of the plant and animal diseases that are common around the world. So government therefore invests in our screening tools to help protect our economy, environment and way of life. With our dog program, at the moment we have 49 operational dogs and 59 handlers nationwide, scattered all around the country in both large ports and small ports. The detector dogs teams deploy to international airports and mail centres primarily to screen incoming travellers and goods for biosecurity risk. So dogs found suitable for our national detector dog training team are flown to Brisbane to commence an 8-week training course to imprint 9 target odours, which is shown in the circles at the bottom of the slide there. Science is behind how we select which traits make a good detector dog, through to how the dogs are trained and their proficiency is maintained over their working careers. You can see Daniel on the video here, one of my dog trainers. He's using behavioural learning to train one of our novice dogs to identify biosecurity risk material. One of the dog's biggest strengths is the ability to generalise targets. So what that means for us is that through the training, the detector dog's odour repertoire expands, promoting items that are similar to, but not the same item they were trained on. So for instance, if a dog's been trained to detect a lemon, it will respond to a grapefruit, which has a very similar scent, in the hope it's going to receive a reward. So once deployed to the board of these 9 target groups we train our dogs on, cover around 200 different commodities they can find, which is pretty impressive. One of the more recent biosecurity risk odours imprinted on our dogs is the brown marmorated stink bug, or BMSB, which is a priority plant pest. BMSB scent samples were created by extracting the volatile organic compounds from the live insects into a suitable solvent, capturing their odour, and those scent extracts were then sent to our detector dog training team to commence the imprinting. And the very first detection of a BMSB was during a cargo inspection of over 800 vehicles, where Velvet, who's the black lab on the screen there, detected a single bug about this big on a massive highway Caterpillar truck. So they're pretty versatile and effective tools. The second half of detection capability is the detection technologies team, which manages our department's X-rays. And as well as our 2D fleet of X-rays, we currently have 7 3D X-ray machines installed at international mail centres, airports, and at a Sydney air cargo facility as part of proof of concept work. The 3D X-ray units produce an instant 3D image when the item passes through the unit. And you can see on the screen the comparison between a 2D X-ray and a 3D X-ray image. But where the real benefits come in with 3D technology over our traditional 2D units is the software's ability to manipulate the 3D image. So on the screen here, you can see a pineapple in a transport hub. And unlike the 2D product, we are able to manipulate that image by rotating it, slicing it, cutting it, and giving our biosecurity officers a much better idea of what is in that bag or parcel and their ability to detect that risk item. Shortly after the first installation of our 3D X-rays in Melbourne Mail Centre, Biosecurity intercepted a large box of concealed succulents. So this package arrived overseas and was falsely declared as closed. And using the 3D manipulation tools, the biosecurity officer are able to identify those succulents before even opening the box. And upon manual inspection, you can see 83 succulents were stuffed to the brim in a couple of cushions that tried to get through the border. So 3D X-ray is used around the world automatically to detect dangerous goods and explosives on outbound flights using detection algorithms. So we've taken that algorithm technology and used it as a platform to develop biosecurity detection algorithms for things like fruit, meat, vegetables, and plants. The department's also partnered with Taronga Zoo, Taronga Conservation Society, to train the algorithm to detect wildlife and trafficable animal products in outgoing mail. So both the detector dogs and X-rays have proven really successful tools in detecting biosecurity risks, but we continue to look to science to modernise our methods. So I'll now hand to Grace to talk about DAF's Diagnostician Network.
Hey everyone, my name is Grace. I'm a plant pathologist as well as a molecular diagnostician working for agriculture biosecurity. To protect Australians' agriculture from exotic pests, plant pathogens, and weed species, we have to identify these organisms first. And that's where we come in as a diagnostician. At the Department of Agriculture, Fisheries and Forestry, we have laboratories in capital cities in all states and territories in Australia. These including some well-designed state-of-the-art facilities. Among all these laboratories, Victoria is unique because in addition to the border lab in like other states, we have a second laboratory based at post-entry quarantine facilities in Midland. Currently in DAF, we have nearly 100 diagnosticians, which make us the largest employer of entomologists in Australia. Working as a diagnostician, we sometimes get to go to the field. In the first image, you can see my colleague Jennifer. She was collecting a specimen in acetate tablelands in the North Queensland. During this trip, she discovered a new fungus, which later was named after her. And that's the coolest part being a diagnostician. We got the chance to name the organism we discovered. Working as diagnostician, we mainly working in laboratories. We do microscope-based morphology identification. Currently, in all the labs, we have a large collection. In this image, you can see my colleague Joseph. He's showing off his favorite tree from the lab collection. Because we are receiving goods from international trade, which means we got to see insects from all over the world, which make our job challenging and interesting. As a diagnostician, we also benefit from the advantage in technology. Currently, we do in-house sequencing. Sequencing is a process. We load the DNA or RNA into the machine, and the machine will read the genetic code. Through that process, we can use the genetic information to identify all the organisms precisely. You may have heard the high demand for GPU for AI training. We use those for genomic data process as well. And working as a molecular diagnostician, I also write code and scripts, which is really super cool in my job. So all the DAF jobs are available at our website, but also for plant pathology, entomology, and molecular biology jobs, they are also available on their respect society website. I get my current job through the society website on plant pathology. These society websites, they are not only providing career information, but a lot of information on conference, workshops, or professional development opportunities. So and also being a student, you can benefit from scholarship and discount to attending these events, which is a fantastic way to grow, learn, and network in your field. Thank you.
Thank you, everyone. If you have any further questions about dogs, x-rays, diagnosticians, biosecurity, DAF in general, we're up at the booth at the back for the next half hour or so. Thanks all.
Just if you are interested to learn more about the sequencing, we actually brought one of the sequencing machines we use in our lab. So please feel free to come and see us at booth 2 on the right-hand corner. Thank you.
G'day. Hi, everyone. Isn't this cool? Isn't this venue awesome? Isn't this expo fantastic? I hope you're all having a good time. My name's Luigi. I'm a research scientist at the Bureau of Meteorology. One of the best things I love about my job is that whatever we do as an organisation, be it a lowly researcher like me, right through to the operational forecasters, whatever we do has an impact on how you live your life on a day-to-day basis. Hopefully this video can give you some insights to how. So hopefully that showed you that we provide a vital service to the public, but we also provide very vital information to industries like aviation, maritime safety, defence, space weather, emergency services, and Antarctic operations. So for information on what's happening in the next few minutes, hours, days, weeks, months, seasons, years, decades, the Bureau of Meteorology remains Australia's trusted source of weather information. So weather is important because it affects the way we live, play and work. And whether it comes about through complex interactions between land, atmosphere and oceans. So our understanding of those interactions is critical for making better weather forecasts. Our understanding of what drives the weather is built on decades of physics and chemistry and is written down in mathematical equations. Those mathematical equations we then turn into computer code, which we call models, and those models run on supercomputers to give us weather predictions. And so if you love maths, science, and computing, you'd love the Bureau of Meteorology. It's nerd heaven. Anyway, so a bit about me. My career really started last century when I finished my Bachelor of Science degree in mathematics. I should say that at high school, I wasn't that really good at maths, but I liked it a lot. I was really passionate about it. And they let me come into university and do a degree. But my university studies culminated in a PhD in physics, where I looked at the interactions of electromagnetic radiation with the Earth atmosphere system, particularly using satellite images. That same year, in 2003, I joined the CSIRO, where I honed my skills on the applications of Earth observations to the application of monitoring water in the landscape. Fast forward to about 2017, and I joined the Australian National University, where in addition to doing my research, I got to work with a wonderful array of students, particularly the ones that are going to go on to be the next generation of weather forecasters and modelers. And then a couple of years ago, I joined the Bureau of Meteorology, where all my knowledge gained over many years has been applied to trying to make our weather forecast better by first of all looking at how we can fix the land surface with satellite images. So I keep talking about satellites. I love satellites. The Bureau of Meteorology uses dozens of satellites to inform the models. Our weather predictions are all based on satellite data, pretty much informing the mathematical equations of what the equations should do. I love working with satellites so much that even in my spare time, I build Lego models of my favorite satellites. Anyway, like I said, nerd heaven, right? So why do I love satellites so much? Because the electromagnetic radiation tells us about what's happening in the Earth, atmosphere, and the land. It tells us the composition and the distribution of stuff in the Earth system. But what we see with our eyes is a very thin slither of the electromagnetic spectrum. So what satellites do is they come and fill in the whole spectrum. They can see things from the X-ray, visible, right through the thermal and into the radio frequencies. And that tells us different information about the Earth system. And that's important for us because we don't have to rely on having 24-hour-a-day sunlight to see what's going on. We can look at different parts of the electromagnetic spectrum and get 24-hour, 7 days a week observation of what's happening in the landscape. So that's one of the reasons. On the left, we've got the thermal imagery, and you're seeing the motion of the atmosphere. We can use that motion to look at where the system's going to move to next. And then you see on the right there, you see the what's called the Earth disk, with the sun day-night transition. So we can see all parts of the electromagnetic spectrum with satellite data, and that helps us make better weather predictions if bring all that stuff together. And so if you bring together maths, a healthy dose of science, and a lot of computing, supercomputing power, that's the study of weather systems, meteorology. So all that comes together to help us make better predictions, which gives you guys better planning opportunities, when to hang out your washing, when to plant your crops, when to harvest, etc. So most of us at the Bureau of Meteorology, we work on, Australian continent, but there's a few of us who get to go to really exotic places like Antarctica, and do some really cool weather stuff there, because the poles do influence what happens in where we live. So I think that's it from me. Please come and talk to us at the booth just over there on my right, booth number 2, I think. Please come and have a chat, and yeah, we'll answer all your questions. Thank you very much.
thank you so much for being here, and I hope you can hear me. Sorry about that. People down the front, I guess you can hear me. People in the back, maybe not so much. All right. Look, thanks for coming. I'm Will Howard, and I'm from the Climate Change Authority, and I'm very lucky to be the lead scientist at the Climate Change Authority. And I'll talk a little bit about my background in just a minute after I talk about the Climate Change Authority. And thank you all for paying attention. And just want to say, first of all, we recognize and acknowledge the First Nations peoples who are part of this land and everywhere else. And that's something we always take care to do. So I want to do that now. And I'll talk about what the Climate Change Authority is. And we're an independent advisory agency. And we live in the environment portfolio, but we independently advise the government. And we provide expert advice on climate change and climate policy. So we advise the government on its annual climate change statement, and we provide an annual progress report, say, how is the nation doing on climate change, climate policy? Are we making progress on emissions? Are we making progress on adapting to climate change? I'll say a bit about that in a minute. And we also advise on, how ambitious we should be in reducing greenhouse gas emissions, which we know are imperative. But we try to advise on how ambitious we should be at any given point. Sometimes we initiate some of our own research, and we've done that. I've led some research on that. And sometimes we are referred by Parliament. We get requests, could you please do a review for us? And we have some responsibilities to review the ACU scheme, which is the scheme in which companies and entities can trade carbon credits that they may generate by things like growing trees or creating soil carbon, and that helps reduce emissions. And also, we advise on reviewing the NGERS Act, which is actually how we measure how much greenhouse gas emissions we have, and it includes some mechanisms for industries to reduce their emissions. So, unlike other departments, we have our own board, and we have a chair, and we report specifically to the climate change and energy minister at the moment. That's Minister Bowen. And we have a new chair who just started literally last week, and that's Mr. Matt Keane, who was previously the Energy and Climate Minister of New South Wales. And he's very energetic and really dedicated to climate action. The chief scientist, Kathy Foley, who's organized this whole event, is also on our board. So we have a range of expertise. We have some climate scientists like Leslie Hughes, who's on our board. We have a range of expertise in sort of technology and engineering, law, economics, because all of those disciplines are required for us to solve the climate problem. And again, I myself have background in oceanography and marine geology, and I've spent a long career studying climate change and the impacts of climate change on the ocean. And that's my own background. We have some people with PhDs in chemistry, physics. We have people with engineering backgrounds. So we have quite a good range of STEM expertise, both on our board and in our secretariat. So a couple things that we're doing now. We just finished what we call our sector pathways review. So we looked at the imperative of decarbonizing and getting to as low in emissions as we can, but for different sectors. So we looked at transport. So for example, transport, how can you build alternative transport systems that don't rely on gasoline and gasoline, petrol and diesel. We looked at agriculture and are there ways to reduce the methane emissions from things like cattle? We looked at the built environment. Can you make buildings more energy efficient and reduce the carbon footprint of our building sector by using more low carbon materials? And there are a lot of alternatives there. So we looked across those sectors. We're going to be advising the government soon on its next commitment. We make commitments every 5 years as part of our contribution to the global climate problem, and it is a global problem. So every country has to make contributions for this to work. So we advise the government on what's Australia's role in this? How can we best contribute to the global effort? And we advise on the annual progress report. We say, well, we've made commitments. We're trying to make progress. Are we making progress? How are we doing? And how is climate change affecting us? And we know it is in many ways. So we're not ourselves a research agency, so we don't do active research the way CSIRO or the Bureau of Meteorology or universities would do. And what our role is to synthesize scientific information. My role specifically is to advise on climate science and the climate impacts that we see. And there's researchers here. We just heard from the Bureau of Meteorology who are working on a lot of research on what are the climate impacts on our natural and built systems. We also advise on technologies. A range of different technologies are going to be needed for us to decarbonize. That includes in transport, things like electric vehicles, different agricultural practices, carbon dioxide removal. We will have to remove a certain amount of carbon dioxide. And for those technologies, many of them are well established. You can go out now if you want and buy an electric vehicle. Those are in the market now. For other technologies, they're still in the research and development phase. And so we try to advise the government on these kind of technologies and when they might be ready to really make a contribution. So again, that brings in our scientific and engineering expertise to advise the government. So we work a lot with many of the agencies who are here. We work very closely with the Bureau of Meteorology, with CSIRO, with Geoscience Australia, and the Australian Bureau of Statistics, and a few others. So we work closely with them, and of course, with DCC, EEW, or DQ, as we call it. So we have very close connections. And what that requires in our agency is people who are very capable in science, who can critically evaluate and critically assess the science and work with science, sometimes setting the agenda, because we'll ask the questions of agencies and say, well, here's the technology. When do you think it's going to be ready? And we ask those kind of questions. We work on climate science, so we advise on things like, is Australia warming? And of course it is. And we try to advise on what the likely impacts of that are going to be. Again, rainfall patterns, and you would have heard from the Bureau or seen from the Bureau, their data are critical for us to understand and anticipate how this climate is changing. And we advise on technology. So what you see there is sort of diagram that looks at different pathways for removing CO2. And for some of those, things like, can you remove carbon dioxide from a smokestack of a coal-fired power station? Yes, you can. It remains expensive. So we try to advise on, are there economically viable ways to do this or remove CO2 from the atmosphere? And yes, there are ways. There are huge challenges to getting that process at scale and getting it economically viable. So we looked a lot on what you see on the right there is actually a little module that removes carbon dioxide from the air. It's a solar powered module. So that's an example of the kind of emerging technology that we look at and why it's great for us to have science and engineering capabilities. So thank you so much for your time. If you want to get in touch, that's how to get in touch with us. And you can look at some of our reports on our website. So thank you very much for your attention.
Good to go. Peg, and I'm so happy to be here back in Australia and to talk to all of you today about my career journey, about opportunities in space and how you too perhaps can even become an astronaut. So would you like to hear about that? Yeah? All right, we're going to start with a video that shows you a little bit about what I've been up to.
To become an astronaut, better yet, an Australian astronaut, is the combination of a childhood dream and the amalgamation of my more adult dream to help grow the Australian space sector. An astronaut is so much more than about a ticket to space. It's about a scientific endeavour. It's about economic opportunity and building our economic complexity as a nation. It's about educational opportunities for our young people in Australia. We've been able to get unique access into this opaque world of human spaceflight, and the door has been cracked open for more Australian scientists and engineers and companies to be involved in all of the scientific and engineering and industrial endeavours to do with space. Internationally, amongst my colleagues in Europe, and when we visited Houston, there was so much interest in what's going on in Australia and, optimism about what Australia could bring to the global space ecosystem in human spaceflight, in microgravity sciences and related activities. Most of all, it's about helping to inspire the next generation, not just into STEM fields, although that's important, but also for them to have the courage to dream big for themselves and their communities and their country, whatever their dream is. And also want kids to know that they should have the confidence to dream big for themselves, because the only limit to their ability to pursue a career path, pursue a life that interests them is their own confidence and their own imagination about what that should be.
It's been an incredible year and a half, but it's also been an incredible journey to get here. I see some high school kids in the audience. How many here are kids at school or university? Amazing. And how many of you would like to go to space if you could? Oh, almost all of you. That's great. When I was at high school, I was just like you. Like many of you are now, I love space, but I didn't really know what engineering was or what a scientist did day to day. I'd never used a drill. I didn't know a capacitor from a line of code. And I thought toilets stopped working when the electricity was off. There's no way I would volunteer to construct IKEA furniture. But I applied to study science and engineering, specifically physics and aeronautical space engineering at university, because the degree had the word space in the title. And I'm so glad I did. I've now spent near to 15 years as a physicist and space engineer, working across 6 countries on some of the greatest missions I could have ever hoped to be part of. Things like being above the polar circle, launching rockets under the aurora, building a satellite to detect gravity waves for the first time, making part of the Orion capsule that's taking humans back around the moon. And from the first spark of an idea, helping to make a new part of the International Space Station. It's been incredible. But 5 years ago, I had finally had the chance to move back to Australia and work in Australia in space when the Australian Space Agency was formed. It was and continues to be an absolute privilege to helping to grow capabilities and opportunities in our sector. And in my time at the Australian Space Agency, I've had the chance to technology scout across the country in adjacent industries, like from our Antarctic expeditions, our mining and energy, our farming, our remote healthcare and management, and defense, and look at what we can spin into space. And we found so much potential. I got to work on proposing the mission concept for the rover that's going back to the moon, now called Rover. And you can see some of the demonstration models for that today here. And I got to work in remote Australia as well, with my feet in the dirt, the red dirt or the white sand, depending on the range, watching rockets being prepared or launching to space. I've been having a ball, but in 2022, I finally got the chance to apply to be an astronaut for the first time, when the European Space Agency opened their first call in 15 years. Now, I learned that to be an astronaut, you can actually have a career in almost any STEM field: science, technology, engineering, maths, including being a pilot or a medical doctor. You just have to follow the one of those that you're most passionate about. You also have to be fit and healthy and have the right mindset to work in a challenging environment far from home with other scientists and engineers and astronauts and get along. So that can be built up through things like expeditions, through team-based hobbies like sports, and then operational hobbies like flying lessons or scuba diving. For those of you at university, I encourage you to look to things like being in the reserves with the military or volunteering with emergency services. They all build a great basis, not just to be an astronaut, but also to have a STEM career where you work with other like-minded people united by a common passion, often under challenging conditions and time pressure to do important work. The astronaut selection process itself was an absolutely incredible adventure in its own right. I was up against about 22,000 other people from 22 countries and went through a year and a half of 6 knockout rounds. And it was just like the movies. They do stress tests, medical tests, technical tests, impromptu speeches, and put you under a lot of pressure. And, you know, at the end, it was such an honor to have the chance to be selected to represent Australia, the first to have the honor to wear this flag on their shoulder. And that's not just an honor for me, but also really wonderful for our country because of what it can unlock for our scientists and engineers to be more involved in human space flight, as well as our educators. And so I'm so excited for what this might do in the future. Now, once selected, you're not called an astronaut right away. When you're selected, you're called an ASCAN or astronaut candidate, and you have to do what's called astronaut basic training. And, you know, that's what I've been doing over the last year and a half and what you saw some of in the video. In the training, we learn about almost any science you can imagine. Because as an astronaut, you're a scientist in the sky, the hands, the eyes, the ears of all the scientists on the ground as you operate their beautiful experiments up there. You learn engineering about how the space station and capsules work and how to fly them. You learn how to do medical procedures on your crewmates and yourself because you're a medical guinea pig for scientists that are looking into making breakthroughs in medicine, things like cancer and osteoporosis. You're a test subject because of the radiation exposure and of the way your body sheds muscle and bone mass and cardiovascular health in microgravity. We do expeditions, winter survival, ocean survival, rescue from heights and depths, and fire to learn how to work well in a team and also handle the environment should we come back not where we're quite meant to. We also learn about how to work in space. We spin up on centrifuges to 6G to go through the launch profile of launch, the G profile of launch and re-entry. We go in the vomit comets to learn how to use tools like drills in space. Because in space, if you don't hold on, you'll spin as well as a drill, which doesn't work too well. Or do CPR by doing a handstand on the patient and squatting on the roof. We scuba dive in deep pools around mock-ups of the space station in buddy teams to simulate how to work out there and learn how to operate the big, beautiful robotic arm of the space station. And it's such an exciting time to be an astronaut. I graduated this year with a class called the Hoppers, 6 of us from across Europe, and we're now ready for assignment to the space station or even beyond. And it's so exciting because we're really at the cusp of the next great industrialization and exploration endeavor for space. Humans are going back to the moon, not to walk, but to work and to learn about Earth in ways we never have before. But there's so many more kinds of job in space than being an astronaut. An astronaut's just the visible tip of the iceberg of space jobs on the ground. Scientists, for example. Scientists in space are those that pose the big questions. we can only solve by putting big telescopes in space or experiments in space. They invent the new technologies to answer those questions. They develop space missions and analyze space data to unlock new knowledge and make concrete steps forward in our understanding of our world and how to live in it. And you can be a scientist in almost any field to work in space. From a strong scientific basis, some scientists also work in policy and science communications and regulation as well. But it goes even further. In fact, if you put the word space in front of it, almost any job can be a space job. Engineers, program managers, lawyers, tradies, artists, even astronaut fitness instructors are legitimate space careers that you can pursue. And the breadth of jobs exists because space ultimately is just a place. It's like the ocean. And like the ocean, it has breadth. Space is just a high point above us from which we can see phenomena around our world and across our vast country. Things like detecting bushfires, seeing floods. And from what you can see up there, you can communicate between 2 points. So you can connect different remote communities. You can talk to emergency services and inform them about the best way to mitigate the disaster that they're managing, or for farmers to be able to smartly manage their crops. In-space labs where astronauts work are breakthroughs for medical research and are helping to combat climate change by making new materials like home insulation and concrete that emits less carbon dioxide. Because in space, when you remove the gravity vector, you can see second and third order effects you can't on Earth. It's also a place to do business. The global space economy is set to triple over the next decade, so we're seeing a rise of startups in Australia and beyond harnessing this economic opportunity. Things like manufacturing long and pure optical fibers in space are quite lucrative. And Australia is growing its space sector in a really exciting way. Unlike when I grew up, it's entirely possible to have a compelling space career in our country. And the opportunities are growing. Launches and returns are ramping up in Australia. We've got a rover going to the moon. Our satellites are becoming increasingly complex and operational. And we've got experiments on the space station. And our space sector is growing at a beautiful time in the global space ecosystem when there's more opportunities right now to capture than ever before. Career opportunities in space exist across many parts of the government, across many agencies here today. In fact, more than 22 government agencies and departments meaningfully use or provide space data. Organisations like CSIRO, Geoscience Australia, the Bureau of Meteorology and Defence. But at the Australian Space Agency, our role is to work across government organisations, industry and academia to advance Australia's position in the global space economy and implement the government's agenda. There are many roles at the Space Agency for those of you that like space, whether that be developing new space programs, advising on technical matters, being somebody that helps us to do launch and returns responsibly and sustainably, representing Australia at the UN, helping us make international agreements with other nations and communicating about science. So I encourage you, all of you that at the beginning that put your hands up saying you're interested to go to space, to absolutely pursue that. If you want to be at the forefront of discovery, if you want to be key to solving problems facing us in our future, space is a wonderful place to work in. And as you do so, as you think to pursue that, I'll leave you with 3 final pieces of advice. The first of all is if you want to work in space or indeed any STEM career, don't think about what you want to be. Think about what you want to contribute. Be purpose-driven. Think about what you want to discover, what problems you want to help solve. And that creates a basis for a career that drives you through the slog that it can sometimes be when you study and start and work on tough projects. Number 2, dream big. Dream arrogantly, dream audaciously, and back yourself. You don't have to be the most talented person in the room to work in space. In fact, you learn more when you're not. What you need is a bit of grit to put in the effort, because effort is more important than talent alone, even on astronaut training. And finally, and perhaps most importantly, follow your passion regardless of whether or not you think you fit in the box, of whether you fit in the stereotype. I certainly didn't fit the stereotype of an engineer when I applied to study at university, and I'm so glad I took the plunge anyway. So come say hi to myself and the space agents at the Australian Space Agency stand over there if you want to chat further. and I wish you all the best for your future.
Hi everyone. My aunt's taking a picture of me right now. That's going to be a really hard speech to follow up. I'm no astronaut and I'm not a chief scientist, but dare I say one day. I also learned my big boss is here as well, so we'll try and make this good. My name is Zane McMillan. I'm a maths and statistics graduate, so I'm not the chief of ABS, but like I said, hopefully I can deliver in some way. And today I just want to show all of you a little glimpse into what we do. And we'll start first with the census. All right. Australian Bureau of Statistics, or the ABS. We probably do statistics, right? Census is kind of our bread and butter, but it's definitely not the only thing we do. The other really important thing that we do is try and give impartial and objective statistics to some of the other government agencies that you see here in order to help make the lives of Australians better. So an example would be we can gather all kinds of economic statistics, health statistics to give to these different agencies to say, hey, we might have a health issue that is of concern or an economic issue of concern. That is our other really important remit. And the other work that we do, which I will plug for myself because this is the area that I work in, is methodology. How do we do the statistics? And it turns out that that's actually a very involved question. Our whole job is to think of the mathematical tools, the technological tools, even the psychology of how people answer questions in order to make more accurate statistics so that we can better the lives of the everyday Australian. And not all statistics need to be boring.
So we can start with an okay one up behind me in the middle. So male versus female scientist. It's a pretty standard stat, right? Get a bit wackier. We can see how we compared to Barbie, because she's killing it with all of her careers, Barbie and Oppenheimer. How's the everyday Australian stacking up to their different careers? And if you're a Swiftie, your heart's set to be broken, right? Because as you can see, it's extremely unlikely that you're going to get a ticket. These statistics seem wacky, and you're seeing a very small portion of the amount of work of, it looks nice, right? But how do we actually publish a statistic, or how do we actually get a statistic out? That's where I introduce you to Greg. This is the generalized regression estimator. We can't get all of our information from the census, right? We want to know things about Australians that we can't ask the census. Like, we can't go and ask every Australian, do you like Taylor Swift, right? It's not worth the time, it's not worth the money, but we can make an estimate. And that's where this comes in behind us. Think of the census as like a scale in balance, right? We know the total percentage of older people in the population and the total percentage of younger people in the population. Think of that like a balanced scale. We could survey this room, for example. How many people in this room like Taylor Swift? We can't actually run it, but trust me, if we could, I think we'd have a lot of good opinions. I would say that in this room, we have an overrepresentation of younger people. So there's a higher percentage of younger people in this room than what's in the actual population, and a lower percentage of older people in this room than what's in the actual population. And behind me with Greg, the weights. So you might be used to seeing the number pi, right? 3.14, whatever. Here, pi is a symbol for a weight, right? And we use these weights to balance the scales. So with Greg, we would reduce the weight of younger people's answers and increase the weight of older people's answers to balance that scale. And these are the kind of mathematical tools and techniques that we look at in order to make our statistics more accurate. So to say 2/3 of Australians like Taylor Swift, I don't know if that's an overestimation, but a lot of people seem to like Taylor Swift. The other really important thing that I wanted to speak to you guys about today is, where can STEM take you? I've had a fair amount of questions here today. Nicola's in the front. I spoke to her earlier, and I did remember her name. She's smiling because I remembered her name. A lot of people ask, well, I can't even tell you how many times I was asked at uni, well, what are you going to do with a maths degree, and what are you going to do with a physics degree? You can do a lot with any STEM degree, and that's the most important part. You get really good problem-solving skills, and those are the skills that not just the ABS is going to look at, but all government agencies that you might apply for, private companies that you apply for, right? They want you to have these really, really good problem-solving skills. And those are going to be invaluable for you and will help you get the jobs that you want, not necessarily what you study. So, in summary, just do something that interests you and you're passionate about, like the the first female astronaut said, follow your passion. You don't need to do statistics to work at the Australian Bureau of Statistics. We do a lot of interesting work. We want a lot of interesting, thoughtful people who have really good problem-solving skills. That's our main thing that we want. Please follow us on social media. For those live streaming at home, you can scan the QR code. It'll take you to our careers website. And please come and ask us any questions. Ask us anything like, what's the wackiest stat we've worked on? What other types of estimators are there? Because Greg isn't just the only estimator. Thank you for your time, and we hope to see you later.
Hello, everybody. Hi. Hi, everyone. I'm Dr. Bobby Serini, and I am the Deputy Director of Questacon, which is the National Science Technology Centre, and our fabulous team is just over there, and I hope you get a chance to go and experiment with some of the activities, check out some of our exhibits. And I feel incredibly lucky because my role at Questacon is to be responsible for all the amazing interactive science and technology that happens there. And today I wanted to introduce you to some of my colleagues and some of the really fun stuff that you can do when you have a career at Questacon, and also what it means to have a career in science communication. So a little bit about me. When I started my career, I had two really big interests. I was really interested in the arts and performing arts in particular, and theatre, and I was also really interested in biology. And when I first started my career, I went to uni and I got a science degree, and I also worked in the theatre as a performer and a stage manager. And then while I got my science career going, I also kept working in theatre, and I found myself thinking, wouldn't it be amazing if I could combine my theatre and art skills and my science skills? And that's when I discovered there is a whole field out there called science communication. And in that field, you can actively combine not just arts and sciences, but lots of different types of interests that you might have for your career. So a little bit about working in science communication. It takes place in so many different places. So at science centres and museums, also at science and research organisations like all the agencies that are here today. It takes place in universities, in schools, and in the media with science journalism. And right now, of course, it takes place in all different ways as we face some of the big technology challenges and the science challenges of the changing world and the changing environment that we live in. So I'm a big enthusiast for science communication, but that's partly because I'm interested in lots of different stuff. And I'm sure as you work out what you might be interested in, coming into Questacon and having a chat with some of our people might be something that helps you work through that. So as I said, I'm in charge of lots of fun and interesting science and technology experiences. It can be exhibitions and exhibits. It can be programs that travel all over the country with interactive learning activities. We support teachers and educators to help them be confident and creative in the classroom. And we work directly with students, of course, with a whole range of different activities you can do at school or at home. So who here has been to Questacon? Yeah? We're going to do a science experiment in our minds. We call it a Gedunken science experiment. I'm thinking, it's a thought experiment. So I want you to think about when you went to Questacon. I want you to recall an experience you might have had there that made you feel curious, excited, maybe a bit confused, maybe made you ask, what's happening? Is there anything that you can think of that left a lasting impression on you? Does anyone want to shout out something? When I think about Questacon, for me, one of the things I remember most is the earthquake house. Now, we've just reopened our earthquake house, so you can go in and check that out. But also the free fall slippery dip slide. Have you been on that? Yeah. So that exhibition is really exciting because it challenges your whole body to experience something, and in the experience of falling, just for that second, and imagine that fall that you take, what happens to your body? Imagine falling in that 1 second. How do you feel in your body? You feel excited, don't you feel scared? That's quite scary, hanging and dropping. You feel nervous. And then you hit the ground and you think, what was that? What just happened? Why did it happen? Now, you will know about gravity, but there's lots of complicated and interesting science that sits behind that experience. So when you go around your everyday life, science communication that brings these experiences to life and create opportunities for you to experiment with your body and with what's happening in the world can be really powerful, and we can remember them for the rest of our lives. And that is some of the work that Questacon does really well. So I wanted to introduce you to some of my colleagues up here on the screen. I'll just have a look at them and introduce you. So you can see I've got my colleague Brett up here in the left-hand corner. Brett is one of our science presenters, and he's out there doing science shows for school students in remote and regional Australia. So one of the lines of work you can get into in your career in science communication is to join us or another science agency as a science presenter or facilitator, working with people just like you all around the country. And this is great if you like to think about science and talk about it, if you like to communicate through experiments and experiences, and if you're really into working with people in a team-based environment. Going down into the bottom left-hand corner, here's a shot taken inside Questacon in our Q Lab. And this is a place where anyone can come to ask questions and participate in science and technology demonstrations and experiments. And this is about building up that questioning and the answering. What's happening here? Why is it happening? If you like working with people and helping them to get hands-on, do some experiments, maybe explain what's going on, you can work as a gallery assistant at Questacon, and there's a great entry-level pathway where you can work as a volunteer or as a casual person, and you can sign up over on our booth to be a casual workforce member and to join our programs. So moving in, you can see around the middle of the screen, someone who's working on an exhibit. This is one of my colleagues in the exhibit fabrication workshop. And you might not know this, but at Questacon, not only do we present great experiences, but we make them from scratch. So if you're the kind of person who feels really creative, who likes design, who likes the arts, who likes to make things with their hands and build things, who likes to get on the tools and make stuff in the shed, a career in our exhibition and production teams can be really rewarding. So in this case, we're making one of the exhibits, and you can see those exhibits over here. And at Questacon, our team members can go from the very early ideas and the research across lots of areas of science and technology, and they'll turn those into ideas for great experiences. So moving on, in our top, or in the middle at the top, you've got a whole bunch of teachers who've gathered together at Questacon, and they're talking to one of our amazing Indigenous staff members, Tegan. And Tegan is talking about two-way learning. How do we learn from 65,000 years of traditional knowledge and experiences and science and studying and understanding the universe? And how do we bring that into the classroom today? How do we work together, First Nations, Australians, and more contemporary Western science ideas, bringing them together to create that unique Australian knowledge base, knowledge of our unique Australian flora and fauna, knowledge of the unique Australian cultural landscape. So that work helping teachers to work in two worlds and walking together is really important for us on our reconciliation journey. Moving along, in the top right-hand corner, are you a storyteller? Do you like reading? Do you like talking about ideas and maybe imagining what that future looks like? Questacon employs a lot of storytellers. Sometimes they're great writers, sometimes they're great speakers. And in this instance, this is one of my colleagues, and she is telling stories about Manunya the butterfly, which is a Ngunnawal tale of the butterfly. And she's telling this story to very young children in our early learning space. And finally, as I said, science communication crosses lots of disciplines. You can work in front of the camera doing virtual science presentations, or you can work behind the camera producing great content and working with high-tech equipment to build up those experiences. And one of the best things about working at Questacon and working in science communication is that you can work all over the world, taking these skills and combining them in really interesting new ways. So if you're interested, a little bit more interested in science communication, there is a great science communication tertiary program over at ANU. At Questacon, we've got entry-level roles that include apprenticeships with our production teams, frontline, as I said, casual work and volunteer work, and also opportunities through the APS entry-level program. So you can look for jobs on the Australian Public Service website, that's apsjobs.gov.au, on the Questacon website for careers. And you can also reach out to your careers advisor at your school, and they've got information about our student training program for high schools. So thanks for having me. I hope you've enjoyed meeting some of my colleagues. Please go and have a chat with my other amazing colleagues over here, and enjoy the rest of your day, and good luck with your choices around science and hopefully science communication.
everyone. My name is Emmy Schutz, and I'm so excited to talk to you this afternoon about my job as a regulatory scientist and all the other amazing opportunities to apply science to regulation in the Australian government. So I'm here today on behalf of the Regulatory Science Network, which is a network of 13 Australian government agencies and departments that are responsible for regulating things like chemicals, organisms, biological agents, food, and therapeutic goods. But let me take a step back. First of all, what even is regulatory science? So at the core, regulation is what keeps us safe and makes sure that the products and technologies that are out there are safe for us and in Australia's best interests. Regulatory science is the application of science to support regulatory objectives. So I like to think of it as a chain that starts with conventional science through to regulatory science and then regulation, where the decisions are made. Regulatory agencies consider the findings of conventional science and apply them to regulatory science, which guides regulators in making decisions. So how is regulatory science different to conventional science? We know that conventional science is the application of the scientific method to understand the world around us. Regulatory science then takes that knowledge and applies it in practice for the purpose of making a decision within a regulatory framework. Where conventional science is forward-looking, speculative, and generates new ideas, reg science takes that and makes decisions based on analysis and interpretation of existing knowledge. And where there are data gaps, conventional science will perform new research, but regulatory science relies on information that we already have. So regulatory science incorporates a wide variety of scientific disciplines, but it is in itself a specialist field. So many regulatory scientists have trained in conventional science and then done on-the-job training to become a regulatory scientist. So why regulatory science? There are many reasons that I could go into, but here are my top three. So number one is the opportunity to turn science into action. As a regulatory scientist, you are using science day in and day out to make decisions with the ultimate purpose of making Australia or the world a safer place. The work that you do has a real positive impact on the safety of people, the environment, animals, you name it. You're using your scientific knowledge and skill set to prevent harm and provide a benefit for all Australians. Number two is that you get to be at the cutting edge of technology, but not just in one specialist field. So as a conventional scientist, you usually become very specialist. You know a lot about a few areas. In regulatory science, you have the opportunity to be so much broader than that. So for example, in my role, I get to be exposed to a range of topics like new pesticide technology, gene drives, RNA interference, but I also need to be across emerging application technologies like drones or precision agriculture. And then we get to ask the really hard and the really fun questions like, how do these new technologies fit into our existing regulatory frameworks? Or what do we need to adapt or change to assess these? And number three is that you get to make an impact outside of the lab. Let's face it, we love science and discoveries and finding out new things, but lab work isn't for all of us. I personally realized this when I was still at the lab at midnight on a Saturday so I could take my yeast out of the incubator at the right time. I love my job as a regulatory scientist because I have opportunities to use my scientific assessment and knowledge and still enjoy a conventional 9 to 5. So hopefully by now you are sold on a career in reg science and you are dying to know where you can work in one of these fabulous organizations. So I'm going to briefly highlight just a few of our reg science network agencies and some of the career opportunities that are available. So first up is the Australian Pesticides or Veterinary Medicines Authority, or the APVMA, where I work. And we're the regulator for agricultural chemicals and veterinary medicines. So we have specialist scientists in areas of chemistry, residues, human health, efficacy and safety, and environment. And then we also have more generalist scientists who take all of those scientific assessments and make regulatory decisions. So if you're interested in working for the APVMA, you can check out our careers page. We also accept graduates through the STEM grad program. Next up is Defence Export Controls, which is part of the Department of Defence. And they're Australia's military and dual-use goods and technology export regulator. So they contribute to Australia's national security and non-proliferation objectives. They have technical assessors that typically have STEM backgrounds and conduct complex assessments of items against the Defence and Strategic Goods list. And they also represent Australia at technical meetings and conduct outreach across government, industry, and academia. So if you're interested in working for DEC, they draw from the Technical and Research Innovation Pathways, the Defence Grad Program. Next up is the TGA, the Therapeutic Goods Administration, and they're part of the Department of Health and Aged Care. The TGA is responsible for ensuring the public has timely access to therapeutic goods that are safe, efficacious, and of high quality. They have around 1,000 staff from diverse backgrounds, such as scientists, medical practitioners, pharmacists, laboratory technicians, compliance inspectors, and investigators. So if you're interested in TGA, they do have a booth here. You can go and talk to them after my talk, or you can find more information on their website. The Australian Safeguards and Non-Proliferation Office, or ASNO, has a goal of enhancing Australian and international security through activities which strengthen the effectiveness of regimes against the proliferation of weapons of mass destruction. They're part of the Department of Foreign Affairs and Trade, and they're both a regulator and also provide expert advice to government. ASNO ensures that Australia's international obligations regarding nuclear materials are met under international agreements. And then finally, there's the National Health and Medical Research Council, or NHMRC. We love acronyms in government. So the NHMRC supports health and medical research through funding, translation of research into evidence-based practice, policy, and guidelines. So they also develop specific guidelines on various aspects of health and healthcare, such as drinking water guidelines and environmental guidelines. The NHMRC offers opportunities for Aboriginal and or Torres Strait Islander students enrolled in an undergraduate or postgraduate degree in a health or medical research science-related field to take a virtual internship in the agency, and applications for the 2024-25 program will open on their website in September. So, that is just a very brief snapshot of some of the careers that are available in regulatory science. I would love to talk to you about it more. I will be at the APVMA booth just over there. If you have any questions about my job, the APVMA, or any of the other regulatory science network agencies, I'd love to hear from you.
Good afternoon and happy Science Week, everyone. Thank you for joining us. My name is Paolo Menaspa. I'm the Chief Science Officer of the Australian Sport Commission and Australian Institute of Sport, and I'm here to talk about science and sport. I wish to acknowledge the traditional owners of the land on which we meet today and to pay my respect to the elders past, present, and emerging. I also recognize the outstanding contribution that Aboriginal and Torres Strait Islander people make to sport in Australia and to celebrate the power of sport to promote reconciliation and reduce inequality. I'm excited to talk to you about the incredible scientific work being undertaken at the Australian Sport Commission and the Australian Institute of Sport and the different scientific career available in STEM. At the Australian Sport Commission, we strive to be at the forefront of sport science and research in Australia. Driving innovation in sport is one of our strategic goals. With a dedicated team of 450 plus staff, our vision is that sport has a place for everyone and deliver results that make Australia proud. Earlier this week, the Australian government has released a new Australian National Science and Research Priority. Similarly, we have our own research priorities, which were developed for the sporting sector and are published in the National Sport Research Agenda, which sets the direction for sport research in Australia. The National Sport Research Agenda will be updated after the upcoming Paralympic Games. Our goal is to ensure that our athletes and coaches have access to the latest scientific advancements and methodologies to ensure that they can play well and win well. One of the priorities for our Science and Research Office is high-quality research. In fact, we want to ensure that decision-making is based on sound scientific evidence. We are always on the lookout for experts in research methods, data, and statistics. If you have a passion for sports and numbers, this could be the perfect place for you to work. Our scientific work includes developing AIS position statements, as well as managing OSPLAY, which is a national survey that helps us understand the level of participation in sport and physical activities in Australia. Another example, in collaboration with CSIRO, we developed the Sporting Megatrends Report, identifying what trends will shape the future of participation and high-performance sports in the next 40 to 20 years in Australia. We also disseminate research through our clearinghouse website, ensuring that valuable insights reach the wider sport community. If you're interested in some of our work, please visit our stand. Amy Morabito, who's our senior sport dietitian, is there to answer all your questions you might have. She's a dietitian. She can provide interesting details on how we support our Olympians and Paralympians. In sport, performance support includes multidisciplinary teams of experts from science-based areas such as biomechanics, nutrition, medicine, psychology, physiotherapy, physiology, strength and conditioning, well-being, skill acquisition, performance analysis, and data. The AIS has a team of highly experienced leaders working together to provide holistic support across all sports. You can see them on the screen, and if you are interested in any of the above disciplines, one day you could be one of our leaders. Our network leads focus on connecting the system, promoting best practices, and fostering people development. They ensure that our athletes receive the best possible support from a well-coordinated team. AIS engineering is all about creating individualized equipment solutions to meet the unique needs of our athletes. Please keep an eye out for some of this equipment in use during the upcoming Paralympic Games. And if you're interested in some equipment that actually was in use during the Olympic Games a couple of weeks ago, you can again visit our stand over there, where Raj Kapoor, our sport engineer, will be able to show you some of that equipment. Whether it's designing specialized equipment, developing innovative training tools, or even data engineer, our engineers are at the cutting edge of sport technology. Our REST Hub focuses on the science behind how athletes can optimize the recovery from training and competition, acclimatize to different environmental conditions, such as heat and altitude, improve their sleep, and efficiently recover from international travel. When the competition are being held in Europe, in Paris, for example, it's crucial for our athletes to have well-planned travel strategies to minimize the effect of jet lag. Our team is dedicated to developing science-backed recovery and travel plans to ensure our athletes can perform at their best when it matters. And again, even when it comes to travel plans, we have some tools at our stand if you want to come and visit and talk about travel, sleep, and recovery. We have various talent programs, including initiatives to encourage women in STEM. We believe in nurturing talent and providing opportunities for everyone to excel in their chosen field. The new ASC graduate program has a focus on developing technical specialists. If you're a recent graduate with a passion for science in sport, this program could be your gateway for an exciting career with us. We have offices in Canberra, Melbourne, Sydney, and even in Italy, where actually you can get an accent like mine. Our reach is global, and we are always looking for talented individuals to join our team. Working at the AIS comes with numerous benefits, including access to our world-class pool, gym, childcare services, and the list goes on. And I was just reminded you can have also free car park. Even better is actually the opportunity to work in a diverse and inclusive environment with continuous learning opportunities. For more information, please visit our website or come to see us in person. Remember, the future of science in sport is bright, and with the home Olympic and Paralympics Games in Brisbane in 2032, there are endless opportunities for those passionate about STEM and sport. Thank you for your time and all the best for your future.
looks right, but I won't know until I, oh. Hey everyone, I'd like to begin by thanking our previous speakers for acknowledging the traditional owners of the building and that all of us are on today. At the CSIRO, we recognise our traditional owners as country's first scientists, and we strive to learn from them and alongside them whenever we can. And I have a tendency to move around when I talk, so if I get away from the microphone, anyone has permission to do this. So I work with artificial intelligence, but I'm not a software engineer. I have driven robots like Spot over there through man-made tunnels, but I'm not a computer scientist. I'm not a technician of any kind. I have done studies in cybersecurity, in annotation of genomes, in protein crystallization, but I'm not an analyst, I'm not a chemist, and I'm not a biologist. Hi, I'm Melanie. I'm a psychological scientist, and I work at the CSIRO. So, psychological scientist, it's not a term that we hear or that we use very often, but if you're sitting there going, well, yeah, it's a psychologist, you're pretty much on the money. I did the equivalent of a 4-year sequence in psychology, an honours degree, and at the end of that, I had a choice to make. I could go down, this path, and do a master's degree and be trained in the kind of psychology we're more familiar with, like clinical or counselling psychology. Or I could go down this other path and do a PhD or a doctorate and become someone who researches psychology. Now, in Australia, only the people that do those master's degrees can register and call themselves a psychologist. It's a protected term. So that's why I'm a psychological scientist or a psychological researcher or a psychological something. So, that's me. But how does a psychological scientist end up in a situation like this? And why are all my awesome colleagues finding it so hilarious? That question's pretty easy to answer. I got far more excited about driving the robot than I thought I was going to be, and I was really bad at it. These people are amazing. I sucked. So they found that very amusing indeed. But in terms of the bigger question, it was almost exactly 3 years ago now. I was just about finished my PhD and I had job alerts set up, probably seek.com, LinkedIn, something like that. And this job alert came up and it was postdoctoral research fellow in human trust in collaborative intelligence systems. And I went, whoa, I've got no idea what that is. So I clicked through the job advert, and as it turned out, 2 special programs at the CSIRO were looking for someone to study how humans develop trust in machines and how that might affect the way we work with artificial intelligence. So those 2 programs were the Responsible Innovation Future Science Platform and the Collaborative Intelligence Future Science Platform. So responsible innovation is about designing and delivering science and technology in ways that are socially responsible. So in this research program, we develop ways to look ahead and examine the social and ethical risks and opportunities of our cutting edge science. We investigate how to foster trust and confidence in the people and the communities, don't do that, the people and communities that are going to be impacted by new discoveries and new technologies. Overall, responsible innovation is a rigorous approach to understanding not just if we can do something, and at CSIRO we love that question, can we do it? Not just understanding if we can do something, but if we should do it. Now, the Collaborative Intelligence Future Science Platform is developing the science we need to make humans and machines work better. Why? Why does it matter? Well, artificial intelligence is not actually always that intelligent. Machines can absolutely work well where the problem is clearly defined. We know that AI is really, really good at repetitive tasks. It's really consistently accurate at things it's been trained to do. You get humans to do the same task over and over and over and over and over and over again. We get bored. We get tired. Our accuracy drops off. Our accuracy, our performance is also affected by social pressures, by stress. On the other hand, there we go. On the other hand, as we saw from our friend in the video there are things that machines struggle with. AI isn't great in new situations. It's not great in situations that require flexibility or critical thinking. But these are things that are strengths of humans. So one approach to this is to continue to train AI to be more and more like humans, to be more and more able to do the things that humans do, to need our input less and less. In the Collaborative Intelligence Future Science platform, our goal is to train machines to be brilliant at the things that machines are good at, but also able to work with humans on a shared goal in ways that make the most of these complementary strengths and weaknesses. So the big idea here is that if we can combine the abilities of humans and machines, we might be able to achieve things that we couldn't do on our own. So where does trust fit into this big idea? Well, trust is critical to our willingness to use AI, but it's not as straightforward as more trust leads to more use, leads to better outcomes. To work safely and effectively with AI, we need our level of trust to be aligned with the capabilities of that system. So what we really, too much trust? Well, we don't want to put too much trust in a system that isn't really reliable, but we don't want to distrust AI that can actually help us. So what we really need to know is what is that right amount of trust and how do we get there? Now, we've got a bit of a head start in that because over recent decades, scientists have found more than 400 different factors that influence how humans trust AI. The difficulty is those factors vary based on what kind of AI we're talking about. So I want you to think for a second, what might affect how much you trust a chatbot that's going to recommend a mobile phone plan? How might that be different to how you decide if you trust a robot being put into an aged care home to support your nana? So my research project is about developing a recipe for trust in these different sorts of applications. And right now I'm working with scientists all the way across the CSIRO in the Collaborative Intelligence Future Science platform to help build 6 examples of these human AI teams. I start by developing a really detailed understanding of the example, try and work out what kinds of challenges a human AI collaboration can solve and what kinds of challenges it might face. And this gives me the information I need to work out what ingredients we need to build trust in that domain and what processes we need to bring it all together and build that effective human AI collaboration. Our hope is that when we demonstrate new ways of working with AI that really value human experience and human expertise, that we'll see it applied further afield, outside science and in workplaces and sectors across Australia, around the world. It's really cool work. Trust in AI is huge right now. You only need to check out the media to see how much chatter there is about whether people trust AI, how to get people to trust AI, how to build AI that's trustworthy, how to make other people build AI that's trustworthy. And amidst all this attention, you might ask, and so many big players coming into the game, you might ask, why do this work at the CSIRO? Well, the first and the main reason for me is that I really want my work to make a difference. And that is literally the purpose of the CSIRO. We exist to help solve Australia's greatest science challenges. I work in AI, don't know if you picked that up, but across our organisation, we've got people working on preventing drug-resistant infection, reducing the impact of drought, ending plastic waste. I know a guy who uses machine learning to monitor the health and well-being of cattle out in remote paddocks. So just imagine he was doing his computer science degree and probably didn't imagine he'd spend quite so much time sitting around talking with cows. And of course, we've got to focus on energy transition and renewable energy. If you think about these sorts of challenges, if you look at the sorts of things that are up here, you might think, as I certainly do, they're so big, they're so complex. We need groups of people working on these, picking them apart. That's what we do. That's what we do at the CSIRO. If you think a little bit more, it might become apparent really quickly, none of these are challenges that one type of science can fix. Let's take energy transition as an example. We need new technology, but we also need to support the communities that technology is going into. We need lots of different kinds of scientists working on the same problem. And that's the second reason that I love working at the CSIRO. I genuinely never know what kind of scientist I'm going to be working alongside next. It could be a bioinformatician, it could be a security analyst, it could be a fish physiologist. I'm learning new things all the time. I absolutely never get bored. The last thing I want to say about these challenges is that they're not things that science can fix on its own. We're good. We're really good. We're not quite that good. We need industry buy-in for one. And industry is the I in CSIRO. Everything that we do is with the end goal of being used somewhere by someone to make things better. And I think we're doing a pretty good job. Next time you use a Wi-Fi hotspot or roll on some AeroGuard, or if anyone out there is wearing extended wear contact lenses today, think of the CSIRO scientists that invented those, or are responsible for the more recent breakthroughs on the screen, or if you go through and follow that link, there's many, many, many more of them. So if you want to use science to address some of the biggest challenges that our society faces today, if you want to do it as a geographer, or as a chemist, or as an economist, or as a sociologist, or as a psychological scientist, the CSIRO might be the place for you. I'm done, but please do come by our booth over there. We've got lots of information about career pathways into the CSIRO, including our scholarships and our studentships. I love talking about my research with AI or trust or responsible innovation. And we've got a number of our other scientists over there ready to talk about some really interesting work in biosecurity, energy, stink bugs. So thank you guys. Have a wonderful day and hope to talk to you later.
So hello everyone, I'm Kathy Foley, Australia's Chief Scientist, back here today. And all I can say is, wow, what a day. The booths have been fantastic, seeing everyone so engaged, and it's been a real highlight for National Science Week, bringing science into Parliament House and also making sure we engage broadly across the country as we beam out all these talks so everyone gets to share. I'm looking at an audience and feeling right at home, seeing many passionate individuals eager to explore the wonders of science, technology, engineering, and mathematics. And we call that, of course, STEM. National Science Week is a time for us to celebrate science and understand the critical role it plays in our daily lives. It's also a great time to help inspire our next generation of STEM experts because Australia needs more engineers, chemists, physicists, IT experts and innovators, and we need their great ideas and skills to benefit humanity. Science is humanity's superpower. It's the pathway to solving our greatest challenges, from climate change to curing cancer, as well as creating new technologies such as quantum computers and the ability to travel to Mars. It's a pathway to stop extinctions and preserve our biodiversity. And good news is, you don't have to be Einstein to study science, but you do need to be curious, and also you need to be open to new possibilities. You need to be the kind of person who likes to ask questions and work away at things until you find an answer. Science, engineering, and maths aren't only for people who want to be a professor at a university. We also need people who want to start businesses and be entrepreneurs. We need people with skills in electronics and IT, people who want to find new ways to look after the environment, people who like inventing, people who have big ideas, and people who like to think about things differently. Critical thinking is really important. Learning by inquiry, asking questions helps to develop it. When I visited several schools, when I held round tables and talked to school students last year as we were doing the preparation to develop the science and technology, the science research priorities released this week, I heard that you school students want to learn to understand, not learn for assessment. I thought that was pretty exciting because I hope this expo gives you a chance to learn about some of the amazing science and technology and STEM activities, often hidden from the everyday, but yet really in plain sight. Technical STEM skills are and will increasingly be essential in our society and economy. And as we transition to a net zero future, while protecting and restoring our environment, this needs us to have a broader discussion about the urgent need to boost our Australian STEM workforce. I spoke about this topic at a STEM Careers Educators Conference recently, and I told the audience that for a child in kindergarten today, the landscape will change quickly over the next 40 years or so. The second half of the 2020s will see massive energy transitions happening, which we need to do if we're going to achieve 83% renewable energy by 2030. By 2040, AI and quantum technologies will be in full swing. And by 2060, we will have a full circular economy. This means that our mineral deposits will no longer be our prosperous foundation for our economy. A circular economy and changing climate will mean we can no longer rely on fossil fuels and iron ore to meet and support our way of life, as it's done for very many decades. New industries such as hydrogen, space, and quantum will be much more familiar to everybody here in the same ways that coal and gas is to us today. Clean energy, artificial intelligence, and other digital technologies, emerging capabilities like robotics, which you're seeing over here, and personalized medtech, these industries will be central to our society when kindergarten students of today are in the workforce. And while the full industry transformation might be a few years down the track, a lot of technology and knowledge is already here at your fingertips. Many of you have had a mobile phone, probably since you were 14 or younger, where you have access to social media and tools like ChatGPT. By the time you're at university, you will have access to quantum computers available on the cloud. These are not just a science fiction future. Today, you can already get your hands on what we call toy or training quantum computers. In fact, Curious Minds had a chance to do that recently with year 9 and 10 girls getting to do their own quantum programming. most people aren't aware of the breadth and diversity of STEM careers. While we know that areas like quantum and cybersecurity will boom, so will the need for vet-trained people, such as electricians. Jobs and Skills Australia has said that Australia will need an additional, listen to this, 21,300 additional electricians by 2050 for us to be able to construct, operate and maintain our new low emissions energy infrastructure. So there's a job there for everybody being an electrician. And to you students here today, we need you to want to become STEM experts in a STEM related field. Engineering, maths, technology and sciences are just at the tip of the iceberg. And there's a lot more to these areas beneath the surface. That's what I want you to take away today. The desire, actually, I don't want to say the desire, the urge to explore the world of the exciting STEM career possibilities in government organisations that you can see here today. I also recognise that not every student in the room knows what it would be like to have a career and what career they want yet. And I have to say that's okay. For me, I had a natural love of science and mathematics at a pretty young age. So I had an idea of what I wanted to be. And I should go through, and I've missed some slides here. This is a picture of me when I was at school, and I wanted to be a high school maths teacher. I never dreamed that I could one day be Australia's chief scientist, so never know what the possibilities are. So regardless of if you know what you want to do now, when you leave school, don't be afraid to dream big. You never know what could happen. I had a brilliant marketing campaign for this event where the employees from our agencies and departments held up a sign, and you see them here today. And the sign was listing the favourite things about their career. And they had the hashtag, "What do you love?" Let me get that here. And I hope you saw it on Instagram, on X and Facebook. My message is to choose a career that you love, something you're passionate about. There's the old saying that says, choose a job you love and you never work a day in your life. And I have to say, I get to do that every day because I love doing what I do. And it's important that you do too. Today is not just about showcasing the incredible achievements of each agency or department. It's about igniting a passion for STEM in every one of you. It's to show you that science isn't just a subject at school to get through. It's fascinating, it's broad, it's diverse, and it's your passport to a world of possibilities, including amazing careers that can change the world. So dive in, see where a career in STEM can take you, and embrace the possibility that you might be Australia's chief scientist one day too. So now I'm going to hand over to Ivan Williams from APANZA, who's going to tell you all about what they do. Over to you, Ivan.
Good afternoon, everyone. And first of all, I think I'd like to thank Professor Foley, Kathy, for an astonishing success of this event. My voice might be sounding a bit tired. I've been talking for about 4.5 hours straight because at the APANZA booth, which is just over there, if you want to come talk later, we're about 3 deep for about 3.5 hours. So again, thank you, Kathy. I think congratulations, it's been a wonderful success. Now I'm about to press the wrong button. Or the right button, no? Yes. Yes. So I'm Ivan. My name's Ivan Williams. I'm the Chief Medical Radiation Scientist for APANZA, which is the Australian Radiation Protection and Nuclear Safety Agency. And we provide advice to government on pretty much the entire electromagnetic spectrum, also particulate, across medical, civilian, radio waves, a lot of the EM spectrum, and nuclear safety, because we are also the Commonwealth regulator in the radiation field. So we actually regulate a number of the the other people who are here. We regulate ANSTO, Defence, CSIRO, etc. And we are aware of the different risks which occur in the different areas which we regulate. And part of our goal of good regulation is to regulate appropriately the risks associated with the business which we are regulating. So we have a licensee-based approach, and again, we can talk to that and provide more information either off our website or come and have a chat at the booth. We're a health advisor. We provide advice into the health effects and the use of radiation in the health environment, from mammography to CT, nuclear med, radiation oncology, but also the potential negative effects of radiation across the electromagnetic spectrum. So we run a UV measurement service. If you go to our website, or if you got to our booth in the first half hour, you would have got a magnetic strip that tells you what the associated risks with different UV levels actually are. And we can provide that information through our website and do that live. So we engage with a number of other bodies here, Cancer Australia, for example, about the consequential risks of being irradiated with UV radiation and what are long-term impacts. So we provide services, and the photo is our anechoic chamber. So this is used for measuring and calibrating and looking at instrumentation available for things like phone networks. So we can calibrate instruments which are used to measure phone towers, and we do that. We also have a hire out capability where people can borrow some of our detectors, and if they're concerned or they're interested, they can measure local EMF fields in their space, and we rent those out from our office in Yallambee. But we're really here as well to talk about career opportunities. And you can hear we've got a whole bunch of areas, and with the structure of our Panzer, we have a medical radiation branch, but we also have a radiation health branch. And these are our operational branches in addition to our regulatory branch. So I look after the medical space, which I think I've described to an extent, but we also have the radiation health services, which really looks at radiation in the environment. So you can talk about this thing like the biota or the biological column, where you have radiation potentially in seawater, in plants, in soil, in the animals which eat animals and the animals which eat plants, and how you can have accretion of radiation within apex predators, different animals. And there are also standard model animals, which are also part of our understanding and how we track an understanding of the radiation within the Australian environment. We also do a lot of laboratory measurements. Most of our measurements that we do are certified by NATA, who are also here today, which demonstrates that we have a competence and ability to perform what we say we can do. And that's integral to the scientific reliability of anything performed in a measurement fashion. And I think you'll find a lot of other people here are essentially needing to demonstrate the same thing, because it's part of the trust in the community that we are independently verifiable as being competent in what we say we can do. From our regulatory arm, we're involved in nuclear physics and engineering because we regulate ANSTO, and we will be involved in one way or another in the regulation of the nuclear-powered submarines. So we need to demonstrate and have on board a competency of engineering in the nuclear reactor space and an ability to regulate in that space. And so if that's an area you're interested in, we also have capability for employment there. We're interested in biomedical science. We've already talked about radiation in the biota. We're also interested in nuclear medicine, which is the delivery via carrier molecules of radioactive materials which emit radiation, gamma, alpha, or beta, for either therapeutic or diagnostic means in patients. So we have an experience and an expertise in that, and it's part of our engagement nationally. We're involved a lot in medical and healthcare, I've also talked about, and we're also very interested in the production of radiopharmaceuticals in and of itself, but also the health impacts or the health risks associated with, say, transporting nuclear medical material from its means of production, maybe at ANSTO, across Australia, how it gets into a hospital, what goes on there, the delivery to the patient, and how the patient is maintained in a safe fashion, not only for themselves, but also for staff. So we're involved in that space as well. We're also involved in work health and safety because we regulate across areas of business involved in the radiation space, and appropriately handling of radiological materials is part of regulation. We're also a part of the emergency management response, where Australia's developed a national response to a radiological emergency. And our PANZA is key in that, in recognition of capability. You'd all be aware, probably the source mislaid in Western Australia a year ago, and how PANZA was actually part of the engagement with that to identify again. And that was really part of an emergency management response. We also, so we have the immediate response, and then also the cleanup or response afterwards. So we also have advice in the government and policy space across our areas of expertise with chemistry, physics, statistics, and also need to look at regulation here. So we also have a number of lawyers in the agency. We have government engagement. We have a comm space, and our PANZA has room and needs to recruit and expertise into all these areas to ensure that our service to the Australian people and the Australian government is maintained. So let me check there's another slide. Do we have any questions? So if you're interested, go to our website for all the detailed information. Our main laboratories are in Melbourne, just south of Greensboro, in a place called Yallambee. It's about 12 to 15 kilometres east of the CBD. It's a very nice, fairly green place to live if you wanted to move in that space. We also maintain the Reef branch in Miranda, just south of Sydney, or south of Sydney CBD. And we have a significant staff and office space there as well. So we can employ across Australia. We also now have an individual working out of South Australia. So we can also demonstrate our ability to work remotely. And I actually think that's probably an opportunity. Go to the website, have a look at what you've been interested in, and keep an eye on the APS job space. And we'd be interested in talking to you. Thank you.
Good afternoon. My name is Dr. Kylie Jones, and I am the AFP's Principal Forensic Scientist. As the Principal Forensic Scientist, my role is primarily responsible for leading and managing the development and the delivery of specialist capabilities that support the operational needs of the Australian Federal Police. And I work alongside the Commander of Forensics, who has responsibility for the day-to-day operational support to AFP investigators by our forensic capabilities. As a member of the GSG, the AFP is excited to be part of the GSG STEM Expo, and I'd like to take this opportunity to thank Dr. Kathy Foley and her team for hosting us and all the other amazing agencies here today to share our collective science and technology with you during National Science Week. When you think of the Australian Federal Police, it may not be natural to also think science and technology or STEM career. However, these types of roles, whether they be within the Forensics Command, as we have here today, or more broadly within some of the other specialist support functions of the AFP, are becoming far more critical in ensuring the success of our mission. As the world continues to digitise, so too is the methodology used to cause harm, and it is our job to not only know and understand how to investigate in traditional circumstances, but also in those that are technology-enabled, less clear, and very challenging. Scientists are trained problem solvers. Where others see ambiguity, we see a puzzle to be solved through exploration or curiosity. Scientists are also the translators, able to convey complexity and uncertainty to audiences of all levels. In the forensic realm, we are the bridge between the evidence and the real world, reconstructing the circumstances, identifying the individuals, or clarifying the methodology used so that proactive changes to legislation can be enacted, for example. As digitisation and technology continues to progress, I'm excited at the prospect of integrating science with technology and emerging tools to ensure our agility, impact, and influence. This in itself is an exciting career prospect. Add to this the direct impact that we can have on providing answers or justice to the victims of crime, or in protecting national security through proactive disruption of offending. It is a career that is unique, fulfilling, and in my opinion, without comparison. I encourage you to go and speak to our members here at the AFP booth, which is off to my right, who will give you an insight into their expertise, roles, and responsibilities, and I myself would love to discuss more with you there also. I will now hand over to our AFP's Chief Scientist, Dr. Simon Walsh, and some of our specialists who have provided a pre-recorded message for today. Thank you so much.
Hi, my name is Dr. Simon Walsh, and I'm the AFP Chief Scientist with responsibility for the Forensic Command. Thank you to Dr. Jones for that introduction. And echoing Dr. Jones, I too would like to express my gratitude to Dr. Foley, Australia's Chief Scientist, for hosting today's STEM Expo event. The AFP Forensic Command is excited to be sharing what we do with you today, showcasing the role that science plays at forensics during National Science Week. Because of the work we do, you may not previously have been exposed to the real science through what you see in the media or on crime shows such as CSI. It's a really important job with a lot of responsibility associated with it. And as a forensic scientist, you have an opportunity to help solve problems that really mean something to the rest of the community, and overall, to help keep our communities safe and secure. And to give you some further insights to some of the science and technical-based roles in the AFP Forensic Command, we have a range of members to follow me, sharing some of their experiences at work and how they came to be employed by the AFP. I hope you enjoy what we have to share.
Forensic science is about people, and it's about understanding our society and helping people in our society to actually understand what's happened to them. We come in after the fact to try and identify what's happened and to find those pieces of information and to use that specialized knowledge that we have to be able to provide them with the information that they need. It's all really about the people. I studied an undergraduate analytical chemistry degree, and then did my PhD in forensic and analytical chemistry. So when the position was advertised with the AFP, I jumped on it and applied for it and came over and interviewed. And on the day of my interview, they had the detection dogs in the building. So I thought, why wouldn't I want to come and work here? When I started, I didn't know that I was interested in forensics. I was interested in applied science and using science to answer questions. My typical day is spent mostly in the lab, which is where I'm happiest. So I typically do a lot of the DNA analysis lab processes. So we might start a day doing some extractions and then move on to our amplifications and follow a sample the whole way through its lab process. So that's where I spend most of my time, is gowned up in the biolabs. Often we'll get phone calls from investigators and they'll say, look, I've got this job or I've got this exhibit and I'm not really sure what you can do with it. And I'll say to them, well, what is it that you're trying to answer? Like, what questions do you have? And we'll tell you what kind of examinations might be able to offer you that type of information. And I find those conversations really rewarding. We are constantly being pushed and challenged to keep building our skill sets and continuing to adapt to the ever-changing scientific landscape. I studied a Bachelor of Medical Science and also a Bachelor of Arts, majoring in archaeology and biological anthropology. I really enjoyed the hands-on and collaborative components of what I did at university, and I thought somewhere like forensics and AFP would be a great opportunity to use those skills. So I ended up applying for the graduate program. One of the best parts about the graduate program was that I was able to take 3 months in different teams across the course of the year, and that gave me the chance to learn a few different skills and see potentially where I could see myself slotting into forensics into the future. What I do day to day is I'm using our facial recognition system to help try and identify suspects who are part of active AFP investigations through one-to-many searches, also working in collaboration with other government agencies. And then additionally, we do one-to-one facial image examinations where I'm comparing an unknown person to a known suspect or victim and using a scientific knowledge of facial anatomy to make a comparison to come to a conclusion as to whether or not I think there's support that these people might be the same person. On the other side of the house, we have our amazing forensic artists who come from a wide variety of backgrounds in art and graphic design, as well as having some scientific knowledge as well. And they do a wide range of capabilities, and these include creating photo boards of suspects that can be presented to witnesses or victims. They also create face fits, so they work with victims or witnesses who have observed a crime or have been victim to a crime, and they sit with them and they bring together facial components to try and recreate the face of the suspect in the case. They do age progressions of long-term missing persons and work really closely with families of missing persons to create what that person might look like now to help see if there's any new leads to try and find this missing person. And also we do craniofacial reconstructions, which is with unidentified human remains. We're taking 3D scans of their skull and we're recreating those to try and see what they would have looked like and trying to identify whether they might be a missing person within Australia. No matter what background you have, come in with an openness and a willingness and be ready to learn. And I think that's the most you can do to prepare yourself to have the best chance of working in an industry like this.
The way that someone in a traditional forensic role would point to a blood stain at a crime scene, I'm trying to do the same thing with something on a mobile phone or something inside of a computer. We call it making the digital crime scene visible to an investigator. I did 2 degrees at university. I was a bit of a perpetual student. I did a Bachelor of Arts in Linguistics, and then after that, I studied computer science. I was working in a corporate role for a few years, and logically, I knew the work mattered, but it didn't feel like the work mattered to me. So I wanted to do something closer to the mission of the AFP. Digital forensics appealed to me because you straddle this really interesting line of doing technical work, but still needing to talk to people. So you need to be nerdy enough to build your own PC, but you need to be social enough to be able to explain that in a courtroom if you need to. I'm interested to come to work because I don't know what's going to happen, and I always know I'm going to learn something new, kind of like being at university. So the work that we do in digital forensics contributes to investigations by making things visible and understandable that might not be visible and understandable without our help. So you have increasing uses of things like encryption, password protection, hardened phones. All of these things, an investigator might not have the know-how or even the software or physical tools that they need to actually see it. I find the work in digital forensics really meaningful because I'm so much closer to the front line of what the AFP actually does. I might be physically there where something's happening. I might be handling a device that has been owned by a criminal. I might be in court reporting. I feel so much closer to the actual work and the mission of the AFP.
Our team is responsible for the classification of prohibited weapons. We're also responsible for the classification of ammunition and firearm and their components and parts. We also go to crime scenes. We detect, record, and collect any firearm-related evidence and do a shooting reconstruction from the physical evidence we find at those scenes. So I enrolled at the University of Western Sydney in a Bachelor of Science, Forensic Science. So I completed that and I came out with a submajor in forensic chemistry as well. When I left uni, a lot of the advice I got was you needed to go sworn. So I started going down that route and I joined the AFP as a PSO, Protective Service Officer. When I was a Protective Service Officer, I went and did postgraduate studies. I got a postgraduate certificate in forensic security, which focused on biowarfare and chemical warfare. And then I did a postgraduate diploma in forensic studies and forensic science. I interviewed for document science and chemical criminalistics, and firearms happens to fall under the umbrella of chemical criminalistics. So I was offered a position in FTI to be a firearm examiner. I can't imagine my life any other way. It's such the perfect blend of scene work and lab-based work, and every job is always different. No two firearm, even if they're the same, ever operate the same or have the same issues. And that's why I love it. Our national training curriculum takes between 5 and 7 years. So I'm about 5 years into mine and hoping to gain expertise next year. One of the most recent cases that I've been working on is Operation Kilcoy, in which we've had 3D printed firearms seized within the ACT. That to us is an emerging threat, an emerging trend. I was able to go into our evidence recovery area, help disassemble those firearms with my knowledge, point them in areas in which they would be able to get manufacturer DNA and biometrics. And I was able to assemble those items again so they were still in working condition. Doesn't matter how many times you apply and how many times you hear no, just keep going and try and find ways in which you can improve on yourself so you do get to that next step so that you can achieve your dream.
Chemical criminalistics is responsible for conducting both physical and chemical examinations and analysis on evidence. Some evidence types include glass, explosives, textile damage, fire debris, soil, and a lot of other miscellaneous chemicals. Crime scenes generally collect the evidence. They will return it to the facility where it will be transferred to us, and we will assess it to see if we can compare that to any other reference material to see if there's a match. After finishing my forensic science degree with honours, I actually spent a few years in other government areas just gaining experience before applying for the graduate position. And I was very fortunate. I got one of 2 positions here at AFP Forensics. I'm not going to lie, it was very hard work. But if I am a model for anything, it's that hard work does pay off. Being part of AFP Forensics, you have what they call PDC training, which is mandatory forensic training that every forensic scientist has to go through. There's 9 stages. As well as that is each team has their own individual workbook, which will involve getting, for instance, for chemical criminalistics, it involves getting sign-off and instrumentation. I'm incredibly happy to be here. It's a once-in-a-lifetime opportunity. To get into AFP Forensics is incredibly hard. It's where the best forensic scientists in Australia want to work. We're constantly coming up with new innovative ideas and technologies to persevere with trends in crime. If you are up for a challenge, it's incredibly fulfilling and rewarding experience. I would really like to be an advocate for people and say, if you don't think you can do it, I'm proof that you can. Just trust in your ability and work hard, and who knows what can happen.
Everyone, I'm Shay Doring. I'm a Senior Principal Research Scientist, and I'm the Director of the Environmental Research Institute of the Supervising Scientist within the Department of Climate Change, Energy, the Environment and Water. For the next 10 minutes, I'll be your tour guide, taking you on a journey through some of the work of the Office of the Supervising Scientist. First, I'd like to acknowledge the traditional owners of country throughout Australia. In particular, I'd like to acknowledge the Larrakia people of Darwin, where our laboratories are based, and the Mirarr people of Kakadu, where we have our field station and conduct most of our field work. So you've probably noticed my bright yellow shirt today. This is part of our fieldwork uniform, and I've worn it to highlight the point that Office of the Supervising Scientist is an operational science unit. Our area of operation is the Alligator Rivers region in Northern Territory, and our role is to protect the people and the environment of the region from the effects of uranium mining. We do this through 4 key activities: by conducting programs of mine site audit and inspection, which we call supervision, by monitoring the environment for any changes caused by mining operations, and by conducting environmental research to better understand the environmental systems of the region and develop science-based standards for their protection. We also provide science-based advice to government decision makers and the community. For context, the Alligator Rivers region is located in the Northern Territory. It covers an area of around 28,000 square kilometres, which makes it more than 10 times bigger than the ACT where we are today. It includes all of Kakadu National Park and part of Western Arnhem Land. Kakadu National Park is World Heritage listed for both its natural and cultural values. And it also includes wetlands of international importance. It's a biodiversity hotspot. It contains the greatest diversity of freshwater fish in Australia, more than 1/3 of Australian bird species, and over 1,600 plant species. The area has also been home to Aboriginal people for more than 65,000 years, making them the oldest living culture on Earth, and it also contains rock art dating back over 20,000 years. It's truly an iconic place and part of Australia's national identity. However, in addition to the cultural and natural wonders of the Alligator Rivers region, the area is also well known for its world-class uranium deposits. Several uranium mines have operated in the region over the past decades. The biggest of these by far is the Ranger mine, which operated for more than 40 years, from 1980 through to 2021. The mine is currently being rehabilitated to meet strict environmental requirements set by government. This includes that the site needs to be rehabilitated to establish an area similar to the adjacent areas of Kakadu National Park. Office of the Supervising Scientist is developing the criteria against which the rehabilitation of the mine will be assessed, and has the key role of advising government of the achievement of these criteria. More than 40 years, we've undertaken environmental research and monitoring around the Ranger uranium mine. Our monitoring uses multiple lines of evidence to detect and quantify any changes in the environment. We conduct chemical monitoring of the water quality in the creeks surrounding the mine, biological monitoring of macroinvertebrate and fish communities downstream of the mine, and radiological monitoring of the radioactivity in air, water, and Aboriginal bush foods. Our monitoring has demonstrated that there's been no significant effects on the environment or public health risks from the operation of the Ranger mine, and that the ecosystems and local communities of Kakadu National Park have remained protected. Our research is currently themed around the key environmental aspects for Ranger mine rehabilitation. These are water and sediment quality, in which we're developing guideline values for aquatic ecosystem protection derived from ecotoxicological studies of local aquatic species. Landform, in which we're modelling the geomorphic stability of the Ranger final landform design to ensure its erosion characteristics are tolerable and that waste products from uranium ore processing will remain isolated from the environment for thousands of years. Ecosystem restoration, which includes understanding the environmental conditions and management practices necessary for plants to grow and survive on a newly constructed landform, and radiation, in which we're characterizing and modeling the radiation exposure pathways to people and the environment to ensure that future use of the area will be safe. Our research is making a real-world difference in protecting Kakadu as one of Australia's greatest natural assets and is providing the key knowledge needed to assess the veracity of the mining company's rehabilitation plans and ensure that their rehabilitation works will meet the strict environmental protection objectives set by government. We're also operationalising leading-edge technologies for faster, smarter, and safer methods of environmental monitoring. This includes drone remote sensing for mine site revegetation for plant species classification, structure, and health, underwater videography for fish community monitoring to reduce crocodile risks to our staff, bioacoustic monitoring for bird diversity mapping from recordings of their calls, camera traps for terrestrial wildlife monitoring, environmental DNA for biodiversity mapping, and the application of machine learning, which is a form of artificial intelligence that we're using for big data analysis. As you can see on the screen, our staff have a diverse range of science backgrounds, which highlights the multidisciplinary skill sets needed to monitor, assess, and support the regulation of mining to achieve best practice environmental outcomes. Many of our staff, including myself, moved from interstate to join the Office of the Supervising Scientist. The attraction was, and still is, in undertaking scientific research that addresses real-world environmental issues and the sense of adventure that comes with living and working in the Northern Territory. For many of us, what started as a short-term contract or secondment opportunity has turned into a multi-year and in some cases multi-decade career in science with the Office of the Supervising Scientist. In closing, I want to assure you that there are exciting, meaningful, and rewarding careers in science in the Australian Public Service, and I hope I've helped shed a little bit of light on this today. Lastly, I'd like to share with you a video of some of our amazing staff talking about their work and showcasing the stunning environment where we apply our science. You can catch me at the Department of Climate Change, Energy and Water booth for any questions that you might have. Thank you.
Hi, I'm Claudia and I'm a freshwater ecologist. Here I'm at Ramara Billabong deploying underwater cameras to monitor for changes in fish communities in waterways around the mine. I love my job because I get to work in beautiful places in Kakadu National Park.
Hi, I'm Jenny. I'm a botanist with the Office of the Supervising Scientist, and I'm out on the Ranger project area surveying plants as seasonal creek lines. These species may be used in the revegetation of the rehabilitated mine. I love my job because I get to be out here and I'm contributing positive restoration outcomes for a long-term mine located in high biodiversity and cultural connection.
G'day, my name's Al and I'm a terrestrial ecologist. I'm out here at Pine Creek setting up pitfall traps for ants. So we're using ants as an indicator species for assessing the rehabilitation of terrestrial ecosystems on mine sites. I love my job because of the variety of the work, the places it takes me, and the people that I get to work with. See ya.
Hi, my name is Vasilia and I work for the Supervising Scientist. I'm an environmental assessment officer and I have just conducted an inspection at Ranger Mine to assess their environmental management systems to ensure that the environment is protected whilst they undertake rehabilitation activities.
Hi, my name is Lily Felder. I'm a radiochemist, and today I am preparing a dust sample for analysis by alpha spectrum. This is part of our continuous monitoring of airborne radioactivity during the rehabilitation of range-leading uranium mines.
Hi, I'm Kaylin. I'm an environmental toxicologist. Here, I'm extracting DNA from soil. This gives us a snapshot of the bacterial community within that soil that allows us to better understand the environment.
Hi, I'm Chris. I'm a freshwater ecologist working with the supervising scientist. Been working with the supervising scientist for over 40 years. Today I'm in Georgetown, Billabong, measuring water depth. We'll use this information in the future to assess sedimentation that might arise from the Ranger mine upstream.
And Andrew Jansen. I'm the Science Operations Lead and the Office of the Chief Remote Pilot within the Department of Climate Change, Energy, Environment and Water.
I am honoured to address you today as Chief Defence Scientist.
That's not me. Keep going and hopefully the slides will appear as I'm going, or if I hit next. So yeah, I work in the Office of the Chief Remote Pilot for DQ. Put simply, we're the drone team. So we use drones to do environmental monitoring for the department to meet its environmental objectives, undertake science and innovation. Let's try again. Cool, and that takes us to amazing places like you can see here in Uluru-Katajuda National Park. So before I get into it, I just wanted to acknowledge the traditional owners and pay respects to elders past, present and emerging. And that's for all the content that you're about to see and on the lands that we're here on today. So there's a lot I could talk about of what the Office of the Chief Remote Pilot does, but seeing as the theme of National Science Week is species survival more than just sustainability, I really want to focus on the science and innovation we work and give you some use cases on how we're actually ensuring the survival of particular species that are vulnerable. So I really want to show, what we do, but then also dig into how we do it and hopefully that spurs some excitement on potential careers, so potential career pathways you could take. So what are drones being used for in the department? So drones are being used for to provide innovative and expert advice grounded in science, so the department can make decisions on the environment. They're used for surveillance, so looking for pests like feral pigs, for doing infrastructure mapping. We also use it to build capability and engage with First Nations people. So it's putting drones in the hands of people that are out on country and working and using it in their everyday job. And then also for safety and culture. So, in our national parks, you can use the drone for search and rescue for people that are lost. So the department has over 100 pilots, and I just wanted to put this collage up here so that you can see the amazing people. I'm fortunate enough to be able to be up here today to show the amazing work that they all do. And you can see plenty of smiles on people's faces. So, it's a pretty exciting and enjoyable job to be doing. So the department has, a drone fleet, and we have everything from small platforms, sub 2 kilos with a camera on it, to these larger, bigger platforms that take off vertically like a helicopter and fly like a plane. They can fly for up to 90 minutes and take, a range of different payloads. So with the drones, they're obviously used for a purpose, and we can mount a variety of sensors on them. And the department has a suite of sensors like high resolution, color imagery, thermal, LiDAR, multi-spec, hyperspec, you name it. So I just wanted to talk about how, people will be doing their everyday job, and they're going to pick up and see how we can innovate and use drones to help complement their work, create efficiencies. And, within our team and the 100 pilots across the department, it takes, a range of different people. So within our team of about 10 people, there's people from all walks of life. So we have people that have come from ex-police force, military, we have ecologists and scientists, we have policy background, software engineering, and that's really what is able to make the work we do happen, by bringing in all those different skill sets and looking at things from a variety of ways. So if you're thinking, oh, I'm not great with drones, I've never seen a drone, that might be a block to going into a career like this. It's not. We like to bring in all those different skill sets. And so, you can see in this screen here, we need people that can think logistically and be able to, cart all this equipment all around the country, and then, sit in hotel rooms and try and troubleshoot equipment when it doesn't work in the field. So I really want to show some of the of really cool projects that are using drones. So we come up with ways to monitor the environment, wildlife monitoring methods. So this is a project out of Uluru Katajuda National Park, and the ranger team out there do an amazing job. And if you don't know what a marla is, it's this little thing I put here on screen. It's a little wallaby. So the rangers out there, they have a monitoring program where it was vulnerable. There was the last population out in the wild. They brought it in, had a fenced enclosure that's predator proof because they're vulnerable to things like cats and foxes. And they're trying to let that species survive and reproduce back to a higher population level. So when we engage with people, rangers on the ground like this, we put up a drone and say, what's possible. So, out in the marla paddock at night with a thermal drone, you can see here, we were sort of expecting, we're able to see marla with a thermal sensor, but it's also the unexpected things that we weren't, thinking that we'd see. So you can see there, those tiny little things are hopping mice, and we're able to see other things like burrows and behavioural observations that people hadn't previously thought of. And you can see a little video there of a marla. They're really small, cute animals. So once we, work out and say, yes, we can use drones to monitor this population, the activity usually involves going out there and coming up with how we'll do it. So this method came up with someone from ex-police force in our team who was, flying it around, working out which is the best way we can see them, and took, that search and rescue approach of putting it on an angle. And, we could see at that angle, we're not getting a lot of heat signatures from everything else, and we can see the marla quite clearly. So we do lots of tests, some rapid experimentation. We also collect high resolution imagery that we can then validate the thermal signatures with, which as you can see over on the right of the screen there. So we can go back and say, okay, was that a marla, or was it, a hot log or something like that that's still holding heat from the day? And then once we've done all our testing, we sort of push ahead with what we think a method would be. So looking at how we would actually do this, we came up with, we've got that angled tilt. How do we get a drone? We get it to fly up and down transect lines. So what you can see in the video there is a drone flying one of these lines that you can see on that top map there. And the drone will just be an automated mission, do its thing, collect video that we can then process later. So what we're able to do is survey the whole area in 2 to 3 hours with a couple of drones, compared to going out and actually physically handling these animals, which can cause stress and is a lot more people and time on the ground. So it's a complementary method that we can use to get population counts. And just to quickly show what that looks like at night. So then, when we're developing these methods, we'll have a whole team swarming out, set up a little workstation, and we've got lots of screens, everyone looking at drones in the air and just checking to see that the method's working. Project that is using drones out in Uluru that the Ranger team has been developing is how you can monitor the Great Desert Skink, which is a jukra. So if you can see there, the picture in the top left, they're also an endangered species, or they're threatened, sorry, and they're vulnerable. So what's really cool about jukra is they create these burrow networks, and they live underground. But then also what they do is you'll have, a family will live in this burrow network, and then they'll come out and they'll have these little latrines. So you'll see all these scat that they put near openings around the burrows. So the ranger team out in Uluru will go out and monitor once a year, do a big survey and see where they're moving. Are they being threatened by foxes and any other large predators, and see if they're moving around the national park. But it's a big effort. It takes 15 to 20 people walking in lines through the park in the heat of the day to try and find them. So what we're able to do is take a drone out, get this really high resolution imagery that you can see in that middle photo there, and we actually worked out we can see those burrow systems, and we can also see them in the thermal imagery as well. Which is really cool to see. So what that enables us to do is to complement the ground survey and fly much larger areas. And then these are just a couple more photos. So you can see in that middle photo there, that's from one of the latrines, and that's their scat, and you can actually see the different size classes. And then, on the right, you can see there's a burrow, and then, so look for the burrow, and then if it's active, there'll be a latrine there. So I was talking before about some of the unintended things that you see when you're out flying a drone. So this one was really cool. We were out mapping a wetland to map vegetation, and we just had one of these other smaller agricultural drones with a multispectral camera on it. We're just flying it around for fun, and looking for fish, just playing. And what we noticed was when we put it into the multispectral viewer, and it calculates a vegetation index because it's used by farmers to see how healthy crops are, we could actually see the fish coming up really bright. We have absolutely no idea why that's happening. We have some theories, but it's just something completely unintended. But this might be a tool using drones that we can get fish population estimates from. So there were 2 big fish there, and then if you have a look here, that's the color on the left and the multispectral on the right. You can see on the left, you get a bit of glare from sun, and maybe in the vegetation you can't see all the fish, but in the multispectral on the right, you can see large schools of fish. So it might change the way we're able to count fish populations in wetlands. And then also, applying the same sensor to other wildlife that we're looking at. So this is a video of a crocodile. So, we need to clear water bodies. The rangers needs to go out and, make sure there's no crocodiles present before they open something to the public. We might be able to use these tools on drones as well. And just quickly, so other ways we're using drones is for buffer grass identification. It was recently announced as a weed, so we can map large areas. We're using AI or machine learning to identify it, and then give us a cover, percent cover, and then we can target where weed spraying needs to go. And then the other thing we do is just large mapping projects to try and get high resolution maps, 3D models, and then terrain models. So we're over at the DQ booth. Come and have a chat if you have any questions, or you can contact us at drones@DQ. Thanks.
I'm honoured. I'm honoured to address you today as Chief Defence Scientist and Head of Defence Science Technology Group. This is an exciting time for defence science. In our ever-evolving strategic environment, our scientists are working hard to address some of defence's trickiest problems. The recently released National Defence Strategy outlines how existing and emerging disruptive technologies will be critical over the coming decade to bring the biggest gains in deterrence and military effectiveness. For DSTG, this means that our innovation, science and technology has never been more central and core to defence. Defence scientists are problem solvers. From our innovators and engineers through to mathematicians, researchers and scientists, our entire STEM workforce provides deep expertise that underpins defence's most sensitive and classified programs. Around 2,300 people work in DSTG, and more than half of those contribute to projects that are focused on the 6 innovation, science and technology priorities that came out of the National Defence Strategy. These 6 priorities were hypersonics, directed energy, trusted autonomy in all domains, quantum technologies, information warfare and long-range fires. To deliver the government's strategy of denial, we must rapidly introduce technologically advanced capabilities into service, and we can't do this alone. Our approach aims to harness our national innovation, science and technology ecosystem. We're committed to deepening our partnerships so that we can build scale in these areas of priority technologies and to strengthen existing partnerships. The Advanced Strategic Capabilities Accelerator, or ASCA for short, is an exemplar of our new approach to defence innovation, science and technology. ASCA works to identify the problems that we need to solve and accelerate how we get about developing together with those leaders from across our community, develop those disruptive new technologies that address defence's most pressing problems. It's a new approach, and it aims to deliver minimum viable capabilities into the hands of the warfighter. And ASCA has just celebrated its first birthday, already having given more than $200 million in innovation contracts over more than 160 projects. At the core of ASCA is its mission program. Missions are ambitious programs that aim within 2 to 3 years to develop operational prototypes into the hands of our services. And it was wonderful a few months ago to have Minister Conroy announce Mission Zero, which is our Ghost Shark program, the extra large uncrewed submarine.
Delivered 1 year early and on budget. Let me repeat that because it's unusual. The first prototype was delivered 1 year early and on budget, and all 3 will be delivered by June 2025. So from conception to full realisation, less than 3 years.
This models a new approach to innovation, where we work with industry early, share risk, and accelerate the delivery of operational prototypes. The first sovereign prototype, the Ghost Shark Alpha, was unveiled earlier this year, a whole year ahead of schedule. And it just shows how we can work differently with defence industry and harness the real strengths of defence science. Of course, our talented STEM workforce are the absolute backbone of all our accomplishments. Over 30% of defence civilian roles and more than 40% of military roles in defence are STEM enabled. Defence's need for STEM-capable staff only grows. We offer numerous entry-level programs for scientists at all stages of their careers, from undergraduate to mid-career, and you'll hear more about these programs shortly. We are deeply committed to diversity because a diverse workforce delivers better results. And until we're at a point where our workforce represents the communities we serve, we know we need to do more. That is why female participation targets in each of these STEM entry programs now are set at 50% to represent that parity with our population. We also offer undergraduate scholarships to women and non-binary people via the Australian Academy of Technological Science and Engineering Elevate program, to give these people a chance to start that rewarding defence science career. No matter where you are in your career, I'd encourage you to visit the Defence Science Technology booth to explore the unique and rewarding options open to you from a career in defence science. Finally, I'd love to invite you to come to the Australian Defence Science Technology and Research Summit, or ADSTAR, in September this year in Canberra. It'll be held from the 17th to the 19th of September and gives you an extraordinary opportunity to engage with our ADF, with our defence scientists, our industry, and explore how you can contribute to extending the art of the possible and delivering to defence. It's a forum for curious minds to come together and collaborate, to learn from thought leaders and experts, and to delve into some of the very latest concepts that will be used to defend Australia. I hope to see you all there.
Good morning, everybody. It's always hard to follow the Chief Defence Scientist. My name's Nigel McGinty. I'm a Chief Technology Officer with Defence Science Technology Group. Let me start by first acknowledging the traditional owners of where we are here today, the Ngunnawal people and their leaders, past, present and emerging. I thought I might start by stepping back in time a little bit. And I'm not sure if anyone recognises what this is. The black box. Of course, not very black, very orange. Why do I have this here? Of course, this was something invented in Australia, not only invented in Australia, invented by scientists at the Defence Science Technology Group many years ago by the gentleman on the left, Mr. David Warren. Importantly, this is a sign of the type of work that we do, where we are, of course, doing detailed, important research, developing new defence capabilities to drive a safe and secure nation for us. But there's spin-offs, there's important elements that actually impact not only the security of our nation, but us all the time, like when we fly. I thought, going back in history again, oh, there we go. Not many people know of this. This is REASAT, Weapons Research Establishment Satellite, launched in the 60s, and we were only or the 70s, and we were the third nation to have a satellite in space through work done with the former areas of Defence Science and Technology Group. Of course, it's hard to follow Professor Munro, our Chief Defence Scientist, and in her presentation she had this slide which really talked about us as a group. We are Australia's second largest publicly funded research agency with over 2,200 scientists, engineers, business professionals who are delivering those outcomes. And we cover all areas of science in quite broad and creative ways. In fact, transdisciplinary, multidisciplinary science is where we see the capability edge is at. So we have focused, detailed, deep technologists. We have science specialists, but we also look at the broader areas, the social sciences and others, to really come together to deliver these outcomes. So I said we're 2,200 people. We are located across all of Australian states, and we also engage extensively internationally to achieve our mission. In the presentation that you saw with Professor Munro, she talked about Ghost Shark as a standout as Mission Zero for ASCA. And autonomous systems is something that is really core to us at the moment with our efforts, our research endeavours. And I thought I might just talk through a few of them here briefly. So on the top left screen, we have Ghost Bat, an autonomous jet aircraft to work in a teamed, collaborative way with the Joint Strike Fighter to really look at new ways in which defence will operate. So that being developed by Boeing and with our input has been truly world leading and transformational. The graphic on the top right being an early version of Ghost Shark, which we've partnered with a company called Anduril to deliver once again a novel way in which we can use autonomous underwater capabilities for the mission of defence. But that doesn't stop at two platforms, of course. We look quite holistically at the way in which we can use commercial products within our sphere of interest, and also about how we can capitalize and use existing capabilities in autonomous ways. And so the picture in the bottom middle is the Torvis program, where we're looking at conventional vehicles and how we apply kits to help make them autonomous or operate in autonomous ways. And on the bottom right, a Sydney company called Osius has developed this through a CTD program many years ago, but really just coming and fielded now. And this is a truly unique capability that the world is looking at, and that is a way to have an autonomous boat, sailcraft, a fixed-wing sailcraft that's able to carry a range of sensors and payloads. So autonomous systems in all shapes, forms and ways are really critical for us and key for us moving forward. And in fact, that was one of the 6 priorities that the government has set out for us in the recent National Defence Strategy. The others being around quantum technology. And for defence and DSTG, quantum technologies offer a new way of sensing and communications and computing that are really important for us. So we have a big program around quantum technologies. We have a big program around the electromagnetic spectrum and computer and the computer space, computer cybersecurity, cyber operations, which really is one of our key priorities moving forward. The information domain is really quite fundamental. Long-range fires, which is a very defence phrase, I know, but I still love this picture. We make rockets. And this is a firing of a rocket at Woomera about 18 months ago. We're about to test fire the largest rocket ever made in Australia in the coming months. Very exciting. And that connects to our hypersonics program, where we're the first nation to create a manoeuvring hypersonic vehicle that could restart in flight. And so all those bits are really very critical and provide us with a military and capability advantage. And directed energy, laser scientists and laser physics is also an area that's really critical for us moving forward. And so there's plenty of ways to get engaged with defence and DSTG that I'd like to just flag here. Professor Munro mentioned it in her video. We have a range of ways. So for university students, we run STEM cadet programs for first year, second year students to come in, where we support your studies and also have you engaged in our organisation on real world impactful problems. We of course have a graduate program, which we really welcome all STEM cadets or STEM graduates to apply and come and explore DSTG as an employment opportunity. We have plenty of pieces that are really very exciting and passionate and important for us that you can be passionate about. And for mid-career, we have the Navigate program. The Navigate program is the program by which we attract mid-career researchers to come into the organisation, look at a career change and step into the defence domain. We have many ways in which you can come and be part of DSTG. And with that, I'd like to thank you for your time. Have a great day. Happy Science Week.
One more. There we go. And it's that one. And is there a lasery thing? Okay. Awesome. Good afternoon, everyone. My name is Dr. Roger Beeden. I'm the Chief Scientist from the Reef Authority. It's a real pleasure to talk to you this afternoon about many ways in which STEM subjects are at the core of what we do to protect the Great Barrier Reef. Before I go on, I just want to acknowledge the traditional owners of all of Australia and their elders past, present and emerging, and the traditional owners that may be present today. I also want to make the reflection there's something like 70 traditional owner groups along the Queensland coast that borders the Great Barrier Reef, and what they see in terms of the Great Barrier Reef is actually sea country. What they mean by sea country is their intertwined connection with that majestic, amazing thing that is the Great Barrier Reef. And they've been looking at the Great Barrier Reef and all of its ecosystems for many thousands of years. In fact, actually, as the world's first scientists in many ways, or Australia's first scientists, they even documented things like the change in sea level rise that led to the modern Great Barrier Reef as we know it today, which is some 7,000 or 8,000 years old. So I want to talk about the Great Barrier Reef in a sort of short way, and please feel free to come and visit us on booth 16 if you'd like to know some more. But the Great Barrier Reef isn't just the corals, which I happen to love. It's actually all of the environments that are the Great Barrier Reef. This is a picture of Whitehaven Beach in the Whitsundays. Very, very visited place, incredibly beautiful. But our job at the Marine Park Authority is to manage the Great Barrier Reef for future generations. We've been doing that for the past 40 or so years, and we do that through the care and protection of the Great Barrier Reef, primarily through the Marine Park. But when we're talking about those future generations, these are my kids out on the Great Barrier Reef, my wife, the reality is it's such an important thing and such a connecting thing for so many people, like it is for traditional owners. We have some amazing facts about the Great Barrier Reef. It can be seen from space. It's the size of Italy. There's something like 6 of the 7 marine turtle species found in the world out on the Great Barrier Reef. 3,000 reefs. It's truly vast by every measure and metric, and that makes it complicated to manage. And the reality is that there are many things that disturb systems, coral reef systems like the Great Barrier Reef. Earlier on this year, we saw 2 back-to-back cyclones, Cyclone Jasper and Cyclone Kirrily. And these can have and do have substantial effects both upon coastal communities and on the structure of things like the Great Barrier Reef. We can have many hundreds of year-old corals bowled around by the wave pressures from cyclones, and we can actually summarise that information in partnership with organisations like the Australian Institute of Marine Science, so we can keep a handle on what's going on. Many of you will be aware that coral reefs around the world are under substantial pressure, particularly as a result of a changing climate. And the phenomena that's on the screen behind me is actually called coral bleaching. And that's the breakdown of the relationship between the animals that are corals. They're very strange. They stay still once they've settled, but they have a relationship with little algae in their tissues that give them most of their food and their colour. When temperatures get too hot, they're like Goldilocks. They like it warm, but not too warm. The reality is that that relationship can break down, and then you can see through to the calcium carbonate chalk skeleton below, and that's what the phenomena is that coral bleaching. At this point, corals are not dead. However, they are significantly stressed. And the important thing to think about is actually what can happen to these massive communities. These are lots of corals on the ocean floor below my son there. Keeping a handle upon what's happening to these reefs over time is a principal part of what we're doing now at the Marine Park Authority. We're having to think about the resilience of the system. What do I mean by that? Well, there's a sort of technical definition, if you like, up there, but really think of it like elasticity. Everybody knows there's some bounce back potential in that elastic band. If you stretch it too far, which is what the risk of climate change is, that can snap and turn into something fundamentally different. That's why we have monitoring programs across the Great Barrier Reef, a critical role for many of the STEM subjects, both in terms of doing the monitoring like this person is doing, but also in terms of the analysis. We're very fortunate we have our own programs and also those of our partner agencies, particularly from AIMS. But what we really want to know is this was what can happen after a cyclone or a bleaching event where you see big areas of coral that have died. The crucial part about that is what do you do about it? And the thing about understanding what's happening to the Great Barrier Reef is that you can then think about targeting management actions. So what's on the screen in front of you is actually an echinoderm. So this is a crown of thorn starfish, which some of you may have heard of. They're big, spiky, venomous starfish. They can get to the size of this one, which would be dinner plate size, and that individual animal can eat its own body weight, its own body size in coral every day. Now, they're not a problem when there's individual animals, but they are a problem when they're in plague proportions. And they've evolved alongside corals to be uniquely adapted to eat very large amounts of coral when their populations boom into outbreaks. Now, we're very fortunate with the science that we actually understand now about where those outbreaks are at points in time. And by tackling that with science and with emerging techniques such as culling those starfish, we can reduce one of the pressures, so we buy time for the resilience of the system to be able to deal with the knocks and shocks that come from a rapidly changing climate. So there's on the screen there is the Eye on the Reef program. That's one of our key programs that we use to keep a handle upon impacts that happen on the Great Barrier Reef and the wonderful other things that you see on the Great Barrier Reef. You can get involved by actually downloading the Eye on the Reef app. It tells you an awful lot about the Great Barrier Reef, as well as enabling you to tell us what you see if you're lucky enough to be out visiting the Great Barrier Reef. And I would say to you, really recommend to you, go out and visit the Great Barrier Reef. It's an extraordinary place. So STEM subjects are also helping us to think about new and emerging technologies. The reality of a changing climate is that we need a wide variety of tools. Some of those are on display again at our partners at the Australian Institute of Marine Science booth over there that talks about some of those emerging technologies. This is actually some of the things that are being done in terms of restoration at a tourism site. We work very closely with the tourism industry. They do local actions, local stewardship actions to look at whether they can enhance the resilience of particular local communities of corals, particularly because they've got so many visitors coming out to the Great Barrier Reef. As the Marine Park Authority, we both regulate tourism, but we also work closely with the tourism industry because they are those people are the ones that actually talk to the millions of visitors that come to visit the Great Barrier Reef every year. And we have extensive partnership programs where we can actually improve people's understanding of what's happening to the Great Barrier Reef because it's such a complex space. So overall, the whole intent of our actions over time are to make sure that we get the best possible future for the reef. The challenge that we face is that climate change is threatening coral reefs around the world. And these systems are not just about the corals, it's about the mangrove systems, it's about the seagrass systems, it's about all of the protected, threatened species like dugongs and turtles, etc., that rely upon those systems. And ultimately, the key role that we see from STEM activities is that it can give us better solutions, better options, but also help us to set the direction of where we go. The reality of the sort of knowledge that we get now is that we can make better decisions about where we should target actions. A bit like I'm old enough to understand what it was like to drive a car when we didn't have GPS, but having these kind of technologies which can help guide where we should go is absolutely critical, alongside new tools and emerging tools and existing tools, and using those in every place that we possibly can to secure the future of the reef. Ultimately, the Reef Authority's job at the moment is using all of what's available at its disposal to tackle the challenge that is a changing climate, and we're committed to doing that along with all of our partners. Ultimately, we're doing it because of that vision that it's about protecting the reef for future generations and really inspiring realistic hope that we can do a very large amount in terms of making sure we protect its resilience into the future. With that, thank you. If you have any questions, please come and see us at booth 16.
Hello everyone, my name is Vimala Rajavelu and I'm the Chief of Plant Breeders' Rights, one of the 4 intellectual property rights administered at IP Australia. I'm joined here today by my colleagues Lachlan Lowe from Patents and Brooke Larnock from Trademarks. As I look out on the sea of faces today, I'm particularly excited to see so many young women in the crowd. When I was your age, there were not many women who contemplated a career in STEM. And I was often one of the few girls taking STEM subjects. Seeing so many young women pursuing STEM today is a game changer. It brings diversity of thought that enriches these fields and unlocks incredible potential. Today, I want to share a personal story with you about a time when I was your age, trying to figure out what subjects to choose for college and university. It's a moment many of you might be facing right now, and I hope my experience can offer some insights and encouragement. As a young person, I was driven by a burning passion for science and to make a difference in people's lives. This led me into the field of pharmacy. It was a world where every day was about helping individuals manage their health, providing the best care and making tangible impacts on their lives. It felt great to see the profound impact one could have on the community. As I gained experience, I realised that my passion for helping people was leading me down a path that was even broader and more impactful than I initially imagined. I transitioned from working directly in pharmacy to taking on a role in the government, where I found myself at the intersection of health and public policy. This is where things started to get really interesting. From making decisions about listing new medicines on the Pharmaceutical Benefit Scheme, leading cutting-edge IT solutions, revolutionising national healthcare, enabling the mobilisation of essential equipment during the pandemic, and streamlining processes in ways I had never imagined. It was like stepping into a new dimension of problem-solving and creativity with STEM at the heart of it all. And just when I thought things couldn't get more interesting, I'm now leading efforts in protecting plant varieties, an incredibly important role that has a huge impact from the food that you eat, on agriculture, the economy, innovation, and on a greener planet. It's pretty amazing to think that science and innovation are behind so many things we often take for granted. So why am I telling you all of this? Because I want you to see that a career in STEM isn't a straight path, but a dynamic and evolving adventure full of opportunities. By choosing STEM, you're not just stepping into a career, you're opening doors to a world of endless possibilities where you can make a real impact. Before I pass the mic to Lachlan, I invite you to visit the IP Australia booth to learn more about how a career in STEM can open doors you never imagined. We also have some fun activities relating to plant breeders' rights. Please come and have a chat with us at the booth if you would like to find out more information on how to start a career in IP. It is a place where you can turn your passion into a career that not only shapes your future, but places you at the forefront of innovation. For those joining us online today, please visit the careers page on the IP Australia website for more information for job opportunities. I will now hand over to Lachlan. Thank you.
Good afternoon. My name's Lachlan, and I can remember from maybe the age of 5 years old that I knew exactly what I wanted to be. I wanted to be a chemist. I wanted to work in a lab, make compounds, create things, maybe be a bit of a mad scientist. I got fun starter kits when I was a kid. I collected gemstones and crystals, and I waited years before I could finally start studying chemistry in earnest in high school. And realized very quickly it just didn't click for me. The concepts were fun, they were enjoyable, but I wanted some more variety in what I was doing. This started a twisting and turning journey that has a happy ending, don't worry, because it was then that I learned that my destiny was in fact to become a physicist. I loved physics in high school. I loved the way it helped me understand the world. It was my best score in year 12, and I went to study a degree of physics at university. Didn't really like physics at the end of that. There was a lot of difficult maths, but more specifically, I didn't like the idea that I'd need to specialize into a very narrow field in order to keep progressing through physics. So I decided to become a doctor. I didn't make it through the first application round. When I sat back to think, I realized that what I actually liked was complex medical science, but also variety. You know, I liked learning about all these different things. That ended up landing me in a degree of biomedical engineering, which truly ended up being the best thing that I could have done. From the beginning, I was really passionate about what I learned biomedical engineers do. Medical devices, prosthetics, genetic engineering. I found myself really interested in the variety of different career opportunities biomedical engineering offered me. I am not working as a biomedical engineer today, which is a shocker given my history. Many of the jobs that originally were available to me out of uni seemed too limited for me. One of my lecturers at uni gave me some really good advice that I keep in mind to this day. That by nature of my further education, there was a lot that I actually ended up being qualified to do. Even if I didn't necessarily study specific subjects, the skills that I got from doing a STEM degree made me able to do different careers. So I broadened my net and started searching for jobs that sparked an interest in me. It took me a while, but I eventually found a job that actually did make use of my biomedical engineering degree, but also the research and analytical skills that I developed over the course of my education. Here I am now, working at IP Australia as a medical device patent examiner. This means that I look at new inventions made by creators all around the world to assess whether they can be granted protection for what they've made. To summarize, I've ended up at a job that really only required the final degree that I did. A degree that I really could have been a lot more diligent about doing in the first place. I could have gone directly there outside of high school, actually. Does that mean I regret the options that I took? That it was a waste of time? Absolutely not. Every different field I studied contributed to where I am now. It's not just the content that I learn in these fields, it's also a way of learning, a way of thinking that each of them has, which is different. I learned to be analytical and approach multiple different ways, or find multiple different ways to approach a problem. I learned to be competent and explain my competence. At my work at IP Australia, I frequently come face to face with some invention, and I don't know how it works. So I use my research skills, and by the end of the day, I've learned something new. I get to do so many things as a medical device patent examiner, more than what my job description states. For example, I'm actually standing here at the GSG Expo talking about my life experiences. I still haven't reached the end of my career journey, and I have no idea what's going to come next. I'm really excited, though, to see what will happen. I'm going to pass you over to Brooke to round us out. Thank you so much.
Good afternoon, everyone. I never thought my love for science and the way the world works would bring me to a place like IP Australia. I mean, some people, like my friend Lachlan, want to be mad scientists, and that's great. But pretty sure no one in the history of the world has thought to themselves as a child, when I grow up, I really want to be a trademarks examiner. I can say that I never really considered a career at IP Australia until fairly late in my own personal journey. I had worked in the APS previously after doing a science degree. I've always loved science and learning about the way that things work, which led me to science in school. And without much of an idea of what I wanted to do, I eventually completed a Bachelor of Science at uni. It gave me the flexibility to choose the subjects that I wanted to do and that I was interested in. But about halfway through my degree, I started to realise that a career in the field probably just wasn't going to be for me. So I looked for other options and I thought, how about education? If you can't teach, I think they say. I love teaching. What a great way to combine my two academic loves. And so it was, I was planning on expanding my education into teaching others, perhaps people like yourselves. The wonders and the joy that is science and the way that the world works. However, a chance conversation with a patent examiner friend of mine actually changed my course. He said to me, "You should become a patent examiner, like our friend Lachlan over here." Just goes to show you how many different paths can lead you to a career with IP Australia, right? And I said, "Look, I don't think they're for me. I actually thought I was underqualified. So take that as you will." I said, "I don't think that's for me." He thought for a minute and then he asked, "Well, what about trademarks?" And I said, "Well, what's a trademark?" Like many of you, I had absolutely no idea that these things exist, but they are certainly all around us. This definitely piqued my curiosity, and so I looked into it and found out a bit more about the wonderful world of trademarks. They're everywhere. It's the we've all been largely oblivious to this fact. It's the Samsung phone that is currently in my pocket, hashtag Android for life. It's the Vessi shoes on my feet. It's the HP computer on your lap, your parents' friend's Toyota, oh, what a feeling, and so on. So trademarks examination can really make you think about the world in a different way. So I applied to become a trademark examiner with IP Australia in 2012. Since then, I've examined thousands, if not tens of thousands of applications. In my roles as a coach and a training team leader, which I am today, I've also helped about 80 different trademark examiners, trainees, begin their own journeys into the fascinating world of trademarks. I've seen the titans of industry duke it out on the register in courtrooms and newspapers all around the world. Katy Perry, anyone? Botox? Even Big Mac and Big Jack controversy of a couple of years ago. Of course, I've played a very, very small role in bringing some great ideas into our lives. I still get a huge kick out of seeing inventions and ideas that I've examined a trademark application for. If you have visited our booth, you will know that I'm kind of responsible for Keep Cup being a trademark right now. So that was one of mine. To me, science is all about being curious and being open to learning whatever we can about the world that we all inhabit. I never thought my journey would bring me here, but I'm certainly glad it did, and hopefully we will see some of you at IP Australia soon. Thank you.
everyone. So I hope everyone's had a fabulous day so far. I know I personally have learned a lot here today. So my name is Emma Deeves, and I'm here to talk to you about the STEM careers that we have available at the TGA. So the TGA is part of the Department of Health and Aged Care, and we are Australia's regulatory authority for therapeutic goods. So we are looking to make sure that our products are safe, are high quality, and they do what they are supposed to be doing. So we're responsible for regulating the entire life cycle of a therapeutic good. So right the way through from manufacture to import and export, supply, advertising, and we also do a lot of work monitoring the market and making sure that we're performing investigations if things are going wrong. So the TGA employs a wide variety of people from a diverse range of scientific disciplines. So we need a really large supply of STEM careers to make sure that we can keep up to date with any new and emerging technologies. We have many areas within the TGA that focus on different regulatory functions. So we have our own laboratories, which have been purpose-built for testing therapeutic goods. We have specialised laboratories and laboratory staff that can perform testing in disciplines including biochemistry, biocompatibility, biotechnology, chemistry, engineering, materials science, medical science, pharmacology, microbiology, molecular biology, veterinary science, and virology. So we cover quite a large range there. So we also have areas available responsible for assessing therapeutic goods before they reach the market. So we have lots of chemists and biochemists, microbiologists and toxicologists who look at the quality of therapeutic goods. So our toxicologists and pharmacologists look at non-clinical data, so such as stability of products. And we also have some medical doctors who look at clinical data, such as the clinical trials for therapeutic goods. So we also monitor our therapeutic goods when they're already available on the market. So we receive a number of adverse event reports from consumers, health professionals, and members of the therapeutic goods industry. We have a dedicated team who is responsible for taking action and addressing any safety concerns that arise. So today, I just wanted to give a brief snapshot of some of the STEM opportunities that TGA can offer. So we have 5 examples to showcase here today, but there are so many more career pathways available at the TGA. So please come and chat to us at our booth to find out some more. So first up, we have our medicines evaluator, which is me. So I am now a strategic reforms officer, but when I first started at the TGA, I was doing a lot of work in medicines evaluation. So I was reviewing how medicines are made and how they are stored to ensure that they are safe and that they are of a high quality. So I love performing this role because I have seen firsthand the effects when medicines are not regulated. And so I love that my work contributes to reducing that risk for Australians. So I started out my career after leaving school wanting to be a genetic counsellor because I thought it would be the perfect blend of laboratory work and patient-based work. So I studied a Bachelor of Genetics at the ANU and then met a genetic counsellor and decided it wasn't quite right for me. So I switched across to a Bachelor of Science and majored in microbiology. So a day in the life of a medicines evaluator, despite the picture, it's actually a lot of desk work, not much lab work. So we go through and review the manufacturing process, and we're looking at quality and we're looking at the quality of the manufacturing process, and we go back to companies and clarify or alter processes as needed if the medicines are not up to standard. So as a microbiologist, I was looking in particular at sterile medicines and making sure that they can maintain their sterility throughout their entire life cycle up until expiry. So this is such an important role because bacterial infections can be so serious, so especially when we're providing medicines to patients who are already sick. So we want to make sure that our manufacturers do have processes in place to stop any potential contamination. So next we have our mechanical engineer, so they design and build specialised rigs to test medical devices to ensure that they are performing as they should be. So our mechanical engineer loves this role because it's the perfect blend of technology and healthcare. And working for the Australian government gives a purpose as we're working for the betterment of the public. So when he left school, he wanted to be an artist, a doctor and an engineer. So he went on and studied some biomedical engineering. So in his day as a mechanical engineer, he plans testing, performs the testing, does a lot of work scanning the horizon for devices for new and emerging technologies. So there's a lot of work upkeeping the test equipment to make sure that we can test our products appropriately, and also reviewing documentation and doing your routine correspondence. So this role is so important because it has a significant impact on Australians. So particularly during COVID, our mechanical engineers tested and recalled respirators that were unsafe or poor quality. Next, we have our analytical chemist who they undertake chemical and physical testing of therapeutic goods. So we're looking to make sure that they contain the right ingredients and that they don't contain any impurities. So they can do a forensic style investigations as well when sometimes we receive products that are unregistered or unlabeled. So he loves learning new skills and being able to apply that knowledge to meet the challenges of the position. And also because his work is bettering the quality of life for people all around the world. So he always knew he wanted to be a scientist, and year 11 chemistry solidified that when he decided he wanted to work in pharmaceuticals. So he went on to study a Bachelor of Science in Applied Chemistry, and now as an analytical chemist, on his typical day, he gets to do a lot of work testing samples that may have caused adverse reactions. So he also does a lot of work receiving samples from the Pacific Island nations and performing testing on those as part of our Pacific Medicines testing program. So this work is so important because it allows us to provide assurance to countries that do not have the capability to test medicines on their own. So we also have another microbiologist, a regulatory microbiologist, who they do work on microbiological quality of sterile and non-sterile products. So they're looking to make sure that sterile products such as injections or implantable devices, so anything that's going inside us, does not have any bacteria present. They're also making sure that non-sterile medicines, such as cough syrups, herbal teas, sunscreens, making sure that they don't have any nasty bacteria in there that can cause infections. So he loves the difference that we make, and performing all of these experiments sparks that creativity and that problem solving, which ends for a very fulfilling career. So he always wanted to work in healthcare because his parents also worked in healthcare, and he wanted to make a difference in the community. So he went on to study a Bachelor of Medical Laboratory Technology and then also a Master's of Laboratory Medicine. So a typical day for a regulatory microbiologist, they get to record results from previous experiments. So one of the things about microbiology is that you have to wait for the bacteria to grow, so you're always a day behind. So he then plans the next lot of experiments and sets up all that testing. So it's also a lot of desk work, so doing some researching and evaluating of the medicines and medical devices. So this role is so important because it ensures the safety and ensures that there are no risks for Australians, and the work that we do impacts so many people. We also have a toxicologist. So a toxicologist is a scientist that works with chemicals and other substances. So they determine if the substance is harmful to humans. And to a toxicologist, everything is a poison, but it just depends on the dose. So they like to ensure that the dose is not going to cause harm. So he loves leading a team of scientists and looking in depth at how medicines work and what happens when they go wrong. So his team works hard to ensure the safety of medicines, chemicals, and substances used in therapeutic goods in Australia. When he left school, he really wanted to be a scientist who was going to find the next great cure. So he went on to do a Bachelor of Science and also a PhD in cardiovascular pharmacology. So a typical day for him, he'd be answering a lot of questions about medicines, chemicals, and substance safety, and also supporting the work of his team of scientists. So they do a lot of work communicating risks related to toxicology of medicines, chemicals, substances, and poisons that we come into contact with. So it's such an important role because it ensures medicines are safe for use by the Australian community. So this is just a small snapshot of the work that we do in STEM. So please come and have a chat with us at our booth. We have lots of scientists available to tell you all about their careers. Thank you. Everyone. My name's Majira Manohar, and I'm an accelerator scientist at ANSTO Centre for Accelerator Science. Some of you may have heard about ANSTO. ANSTO is Australia's only nuclear reactor. It has been safely operating for over 70 years. All our reactors are research reactors, and they are being used for the production of nuclear medicine, for scientific research, technology, and to support industry. I want to kick off my presentation with a video to showcase some of the exciting STEM work that we do at ANSTO. Was a quick snapshot of some of the innovative things that we do at ANSTO. Today, I'll be talking to you about my career at ANSTO. I joined ANSTO as a chemist in 2016, shortly after finishing my PhD in chemistry. I then jumped to applied physics when I joined the Centre for Accelerator Science in 2018 as an accelerator scientist. The Centre for Accelerator Science is home to 4 particle accelerators. These accelerators are used to support research and industry communities to understand the past, explore the present, and innovate new technologies for the future. Some projects that we're involved in include looking at radiocarbon dating for understanding things like climate change. We also look at space research and cutting-edge materials research, as well as a whole range of environmental research. It's never been more important than now to invest in environmental research. My team is involved in an ion beam analysis area. We use ion beam analysis to look at projects such as air pollution and to help industry phase out the use of per and polyfluoroalkylated substances in consumer goods known as PFAS. This is what drives me, that my STEM qualifications enable me to contribute to fields that I'm passionate about, which are health and environment. On the next slide, I'll show you a simulated video of how ion beam analysis works. Here you will see a proton beam interacting with an unknown material. As it interacts, it gives off different types of radiation. This is subatomic interactions. We use this to study virtually any material and determine its elemental composition. That is, what is it made of? And this is the key technique that we use for our aerosol research, where we place an aerosol filter in the path of a beam and determine its elemental composition. What are the pollutants made of? As mentioned, I joined the Centre for Accelerator Science in 2018. However, the aerosol research in our team has been going for over 30 years. We have been working with numerous stakeholders, including regulators such as environmental protection agencies. We work with international researchers such as the United Nations International Atomic Energy Agency, and we work with industries such as mining industries. What are we looking at? We are looking at fine particle pollutants. When I talk about fine particle pollutants, I refer to particulate matter that is 2.5 microns and smaller. That's really small. In fact, it's around 30 times smaller than the width of a single strand of hair. And why are we interested in this size? This size of particle, it can overcome the natural defenses in our body. It can enter our airways and get into our bloodstream and be transported around the body, causing a whole range of disease states. But we have relatively clean air in Australia, right? Well, with our air the way it is, it still contributes to almost 3,000 deaths annually. That's around 3 times greater than road fatalities. Globally, the impact of fine particle pollutants is around 5 million deaths annually. This is why fine particle pollutants matter and why we are studying it. And it's not just the health impacts, it's also climate impacts. For instance, the 2019 bushfires that happened in Australia, they were transported long range. They were found in New Zealand and in South America. And when you find soot from bushfires land on snow and ice, they absorb heat and they cause the snow and ice to melt. So it contributes to climate change as well as human health. This is where sampling programs such as ours come in. We measure fine particle pollution. We collect it on filters. We weigh that to find out how much pollutants was collected on a particular day. This is what the regulators look for. They look for the mass. What we do is we go beyond the mass. We place these filters in the path of the beam produced by our particle accelerators to determine the elemental composition of the filter. Once we know all the unique elements on the filter and the concentrations present, we then identify relationships between these elements, and this enables us to identify source fingerprints. For instance, soil is made up of typical elements such as titanium, aluminium, silicon, calcium, and iron. When these move in particular ratios, we know that that source is soil. Similarly, we can also identify other sources such as salt from sea spray, bushfire smoke, volcanoes, domestic heating emissions, agricultural sources, automobiles, coal-fired power stations, and many more. Once we identify these unique source fingerprints, we don't stop here. We do some more statistical modeling. This is where we combine the source fingerprints with wind data. This enables us to tell the likely location of the pollutant. On the next slide, I want to present a case study to show the measurable impact of the work that we do. This work was done collaboratively with CSIRO, and also it was commissioned by the New South Wales Government and Office of Environment and Heritage. The study was looking at an industrial area that was close to residential areas as well. They wanted to see the fine particle pollutants in that region. We helped identify the makeup of the fine particle pollutants, all the different pollutants that were there. What we did find was that there was a fingerprint for industrial nitrates that was in exceedance. Once we identified the fingerprint, we combined it with wind data to identify the likely location that this pollutant was coming from. As you can see from the plot, there's a plot to show northeast, south, and west. You can see the red section, which shows the concentration of these industrial nitrates, and they're coming predominantly from a northwesterly direction. And lo and behold, northwest to our sampling site, there was an industrial nitrate manufacturing plant. And the regulators took swift action. They told the industry responsible, they made them aware of it. The industry committed $39 million to upgrade their facility, and they ceased polluting that community. This is the impact of the work that we do and why STEM is such a rewarding career path. You never know where your STEM career might take you. I was in chemistry, now I'm in applied physics. So who knows where your STEM career might take you one day. Thank you very much. If you have any questions for me, come and see me at the ANSTO booth. If you'd like to hear more about graduate opportunities and postgraduate opportunities, scan the QR code shown. If you'd like to come to ANSTO and book a tour, follow the link and book a tour with our friendly Discovery Center team. Thanks, everyone.
Afternoon, everyone. Thank you so much for attending the GSG STEM Expo. We're just letting you know that the event ends in 10 minutes at 4 o'clock, at which point we'll be asking you to leave the hall. Thank you, and we hope that you enjoy the next 10 minutes.